Hello there and welcome to the Sleepy Science Channel. Tonight, we'll be drifting through the magnificent forces of nature, the hidden machinery of the universe, and the deep laws that choreograph every movement in the cosmos. These forces are as old as creation itself and just as mysterious. All around you, unseen powers are at work, quiet, relentless, and everywhere at once. They hold the stars in their dance, glue atoms together, and spin galaxies like a cosmic ballet. You can't see them, but you feel their pull every second. They are the silent sculptors of reality, the reason the universe stays whole instead of flying apart. From the gentle tug that keeps your feet on the floor to the invisible threads weaving space and time together, these forces are the ultimate connectors of everything that ever was. If you enjoy these quiet journeys through the mysteries of existence, take a moment to like, subscribe, or drop a comment below. It helps other sleepy souls find their way here too. For now, all you need to do is relax, let your breathing slow, let your mind drift into the calm expanse between thought and wonder. Let's begin with gravity, the universe's soft-spoken tyrant. Gravity is so weak that you defeat it every time you lift your hand. Yet it feels powerful because it keeps oceans from escaping into the sky and the moon from ghosting Earth on social media. Compared to the other forces of nature, though, it's laughably weak. You can overpower the pull of an entire planet with nothing but biceps and breakfast. The electrical forces in your muscles are trillions of times stronger. But gravity plays the long game, it never cancels out. Every grain of sand, every planet, every star pulls on everything else, all the time. The sum of all that gentle tugging becomes a web stretching across the universe, delicate but unbreakable. This quiet persistence is why gravity wins on the cosmic stage. It's the ultimate paradox. The weakest force is the one holding everything together, a whisper of attraction binding galaxies, stars, dust, and dreams. Across billions of light years, it keeps the universe from unraveling like a badly knitted scarf. Imagine standing outside the Milky Way, where you'd witness a stunning celestial ballet of hundreds of billions of stars twirling around an invisible center. Each star gracefully glides along the warped fabric of space-time, a dance choreographed by the authoritative hand of gravity. It's a majestic sight, with galaxies swirling like shimmering diamonds, held together in a cosmic embrace, while dark matter, the universe's mysterious heavyweight, adds depth to this gravitational pull. As the ages drift by, galaxies don't just twinkle and shine, they slowly glide towards one another, engaging in a thrilling slow-motion waltz. Picture two cosmic dance partners slowly merging, sometimes taking billions of years to complete this elaborate performance. It's like watching a romantic epic unfold on a galactic scale, where clusters of galaxies join in what we call a cosmic tango, each twist and turn sculpting the architecture of the universe itself. This graceful cosmic choreography doesn't end with galaxies. It stretches out on a grand scale. Clusters form delicate filaments, interconnecting like an intricate web of cosmic spaghetti. Every strand of this weave contributes to the vast quilt that is our observable universe. It's impressive to think that the same simple laws that keep apples plummeting to Earth are also orchestrating this grand performance on a universal stage. The weakest force in physics plays the role of a celestial sculptor. Now, let's flip the perspective and take a look at the everyday scenario. Most of us might think gravity is a big deal only for planets and stars. But oh boy, Einstein knew better. Believe it or not, even your tiny self with your adorable mass is bending space-time right now, yes. Right this minute, your physical presence is warping the universe in minuscule ways. That comfortable chair you're lounging in, it's also doing its part in this cosmic ballet, distorting the very fabric of reality. Let's get a bit more intimate. Your body is gently nudging photons as they zoom by, just like an unseen force directing a parade. While the shifts you create are microscopic, they ripple outward indefinitely, leaving behind faint imprints of your existence on the sprawling canvas of the cosmos. Gravity is less about feeling and more about being. You're not just a spectator but an active participant in this monumental existence, intrinsically linked to the stars. And here's a fun twist. Gravity doesn't just keep our feet on the ground, it has a nifty trick of bending light too. When light dances close to something hefty like a massive galaxy, it aligns with the curvature of space-time. Those photons aren't pulled, they're simply following the wavy pathways of reality. This captivating phenomenon, known as gravitational lensing, expands our vision of the universe, allowing us to glimpse galaxies billions of light years away. appearing as magnificent rings and ghostly duplicates in the cosmic canvas. So next time you catch a glimpse of the night sky or marvel at a distant galaxy, remember this: you're not merely an observer. You're a tiny yet significant part of a majestic cosmic ballet, influencing and shaping the universe in ways that tether you to the stars. It's a wild ride, the grand symphony of existence, with gravity keeping time and making sure that even the smallest beings leave their unique prints upon the vastness of the cosmos. How's that for a cosmic legacy? Imagine the universe as a colossal cosmic telescope, where gravity plays the role of an overzealous magnifying glass. Astronomers get to investigate the early universe through natural lenses created by massive galaxies. These celestial giants twist light, allowing it to loop around them, reaching us in multiple directions. It's like a grand cosmic game of telephone, revealing secrets that have traveled for eons. Who knew gravity could be both a magician and a giant, right? Now, let's dive deeper. Picture the universe as an expansive ocean, but instead of water, it's filled with the fabric of space-time. When monumental objects, like black holes or neutron stars, wade through this cosmic sea, they stir up waves. These ripples, known as gravitational waves, stretch and shake the very essence of reality. It's a dance of celestial bodies, grooving to the rhythm of their own gravitational force while making us mere earthlings feel like we're experiencing a cosmic serenade. When two black holes engage in a spiraling tango, they unleash a fireworks show beyond anyone's wildest dreams. In mere fractions of a second, these cosmic couples radiate more energy than all the stars in the observable universe combined. However, instead of dazzling light beams, it's the gravitational waves that take center stage, profound yet elusive. It's like the universe throwing a surprise party. And all we can do is marvel at the chaos left behind. What's magical is how this energy comes to life. Forget about explosions or burning fuel. It's all about their motion and rotation, mixed with the strange geometry of space-time itself. As these celestial gladiators collide and merge, they form an even larger black hole, an entity smoother and darker. It's like the universe's way of saying, "Hit me with your best shot," and then quietly moving on, leaving ripples that resonate through time. The aftermath of these monumental events is a silent symphony lost in the vastness of space. Yet it's anything but dull. With each collision, the memory of the explosive moment is woven into the very fabric of the cosmos. The echoes of their battles hurtle through space, a reminder that even in the depths of darkness, the universe continues to express itself. It's proof of the universe's quirky humor, singing its truths in whispers and roars, all thanks to gravity. Oh, and speaking of gravity, it's not just about the weightiness of apples falling from trees. It moves at the speed of light, allowing ripples of cosmic news to travel across the universe swiftly, no more considering it an instant action. This revelation transforms how we perceive those silent events taking place millions of light years away, turning the cosmos into a dramatic stage where gravity coordinates the show, patiently waiting for us to catch on. So, the next time you gaze up at the night sky, think of all the unsung songs playing in the universe. Every star, every black hole, is a part of an epic story that's still being written. And while we may be grounded on terra firma, the grand cosmic ballet above us is a reminder that even the darkest corners of the universe have their way of lighting up the stage. It's an engaging, whimsical dance that never truly ends. For centuries, gravity was our cosmic puppet master, an unseen string pulling us all together. If the sun were to vanish, Newton believed Earth would feel that tug instantly, like a dramatic cosmic oops. But then came Einstein, tipping the apple cart of physics and revealing that gravity isn't some force shooting through the cosmos. It's more of a party trick, a bending and twisting of space itself, responding to mass. And guess what? This spatial shimmy operates at the speed of light, no instant effects here. When the sun shifts its position, Earth doesn't feel the change right away. Nope. It takes about 8 minutes, just enough time for our solar sidekick's warm rays to travel those millions of miles and arrive at our doorstep. This incredible insight links gravity with all pieces of physics, keeping everything orderly and removing pesky time travel paradoxes that could seriously annoy a time traveler. So, instead of instant gravitational pull, we get ripples in the fabric of space-time, grooving outward at light speed. And speaking of weirdness, Einstein's revelations don't stop at bending space, they mess with time. Imagine this. Your head's clock is ticking a bit faster than your feet's, in stronger gravitational fields, time slows down. So if you're lounging in a basement, your clock is lagging behind the one on a mountaintop. This isn't just theory. Atomic clocks placed at different altitudes show measurable differences. Astronauts, take note. This is why you'll want a head start on those time-lapse sitcoms. Now, if you think this time dilation is pretty nifty, wait until you hear about black holes. Hang on to your space helmets, because near these cosmic vacuum cleaners, seconds can stretch into centuries. Time gets all bendy when mass clumps up, making it a flexible dimension. Around massive celestial bodies, time crawls, whereas in the vast emptiness of space, it gallivants freely. Every clock out there is cinched with its local gravitational rhythm. Who knew time kept a DJ hat just for that? But let's not forget about our little blue planet. You'd think gravity would be consistent. Right, wrong. Earth is like a geometric playground, with gravity fluctuating based on where you stand. It's like gravity is winking at you from the mountains and saying, "Come here, my dense rock friend." Meanwhile, deep ocean basins give a subtle shrug, maintaining a lighter grip on gravity. So, if you're planning a vacation, keep in mind that you might be feeling a little lighter on the beach. The complexity of Earth's gravitational field morphs with its landscape, elevation, density, and even the swirling magma beneath our feet play their parts in shaping this cosmic ballet. Those hefty mountains create a stronger pull, while glacial expanses and ocean depths offer a unique dance of lightweight gravity. It's a constant interplay, ensuring gravity isn't just an afterthought in this grand theater of the universe. It's a leading actor taking all the right turns. So next time you glance at a clock or feel that gentle tug of gravity, remember it's not all as simple as it seems. It's a vibrant, swirling mixture of forces, relationships, and cosmic quirks, proving once and for all that even in the simplest things, the universe loves to keep it interesting. Picture this: satellites zipping above us, hunting for tiny variations in gravity that are so minuscule, they'd barely register on a scale. These little quirks of weight, just a few millionths of a gram, form a map of the Earth's hidden life, tracking polar ice melts, groundwater changes, and geoid structures beneath our feet. The geoid is like Earth's gravity shape, a quirky, wobbly masterpiece that, unbeknownst to us, shifts as the planet breathes, all while we innocently munch on snacks. Ever wonder why astronauts float around like they're in some cosmic dance? Buckle up. They aren't levitating due to a cosmic magnet, but are falling forever around our lovely blue planet. Yep, they're in a constant honeymoon of free fall aboard the International Space Station, which is only a few hundred kilometers above us. Their weightlessness results from the station's rapid forward motion, and as it tumbles toward Earth, the ground plays a cheeky game, curving away at the same speed. Imagine a perpetual free fall where everything a floating sandwich, tools, or even a water droplet falls together. That's what happens in the space station, creating wacky but wonderful weightlessness. The magic lies in a sophisticated dance between gravity pulling down and the speed of the station moving sideways. They found a sweet spot, turning the act of falling into a glamorous orbit, gently mingling speed and weightlessness in an unending cosmic serenity. Even more fascinating is how a single photon, that little particle of light without mass, can act like a cosmic push. These invisible rock stars carry momentum and can actually give a gentle nudge to a solar sail in the chilly void of space. It's like a quiet high five from the universe. When photons hit a surface, they deliver a delicate poke known as radiation pressure, easily overlooked on Earth but a remarkable force in space. Now, picture solar sails, massive, shiny, mirror-like sheets designed to catch those dancing photons and convert that soft push into graceful motion. That's right, the Japanese spacecraft Yaros showcased this magic, proving that sunlight alone could propel a vessel through the expanse of space, with billions of photons cheerfully nudging the sail forward every second. It's a patience game, slow but steady wins this race. What a dazzling idea, right? A ship sailing on beams of sunlight, gliding through the cosmos thanks to tiny nudges from the light. This unique propulsion method captures the essence of elegance and innovation, blending science with a sprinkle of cosmic whimsy. So the next time you see sunlight streaming through your window, rejoice. It's not just warming your face, it's also busy winging spacecraft into the infinite blue beyond. Picture this, a future where we zoom across the cosmos thanks to lasers propelling sails at mind-boggling speeds. Forget spending eons traveling between stars. Imagine crossing those vast stretches in mere decades. That's right, light, the ultimate energy superhero, moves celestial bodies with nary a touch, proving that sometimes the best journeys are made without fuel, noise, or those pesky engines. Fasten your seatbelts. Interstellar road trips are just around the corner. At the heart of all this cosmic shenanigans is electromagnetism, our shared omnipotent force. Imagine electricity, magnetism, and light all as the three best friends of the universe, having a fabulous group hug. This revelation came courtesy of James Clerk Maxwell in the 19th century, a genius who cracked the code connecting electric and magnetic fields like they were dance partners gliding across the floor. It's a dazzling truth. One influences the other, creating a spectacular performance, known as electromagnetic waves that sprint through space at the speed of light. Let's take a moment to appreciate the magic in everyday life thanks to electromagnetism. Consider how the twinkling of stars, the lively hum of nearby power lines, or even nature's electrifying sparks of lightning share a common lineage. They all emerge from the same fundamental interaction, which weaves energy through the universe. Every beautiful sight you take in and every melodious sound you encounter is thanks to this vibrant force, making life just a touch more thrilling. Now, if you thought electricity and magnetism were rivals, guess again. For centuries, people thought they were distinct forces, one producing dazzling sparks, the other guiding your compass northward. But lo and behold, scientists uncovered that they were actually two halves of the same whole, intricately united in the electromagnetic field. Simply nudge an electric charge, and voila, a magnetic field pops into existence. Change that magnetic field, and you can flow an electric current like magic. The energetic dance between electricity and magnetism is what keeps the universe alive and buzzing. It's the very reason why light beams down from the sun while radio waves serenade us across empty space. Even in pitch-black darkness, the electromagnetic field is pulsing and shimmering, crammed with quantum energy that plays hide-and-seek with particles darting in and out of existence. This buzzing life energy creates everything from gentle sunlight to the more boisterous X-rays, each a different flavor of the same electromagnetic song. So, at the end of the day, electricity and magnetism are not mere rivals but rather tight-knit partners in the grand structure of reality itself. They are forever interwoven, making possible the cohesive fabric of our universe. Without good old electromagnetism, atoms would throw a wild party and fall apart instantly, leaving a chaotic breakdance of energy. Instead, thanks to this incredible force, we can enjoy a structured universe, enjoying a harmonious waltz. So next time you flip a switch or hear the crackle of static, give a nod to those invisible forces shaping our very existence. Within every atom, a bustling hub exists known as the nucleus, where protons and neutrons gather like firm-handed bouncers at a club. Each of them is surrounded by a lively cloud of electrons, who cling on for dear life thanks to the powerful magnetism of opposites. The negative charges of the electrons are irresistibly drawn to the positive charges of the nucleus, creating a delightful balance. Without this electric love story, our tangible world would simply dissolve into a chaotic mess of free-floating particles. But wait, things aren't that simple. In this atomic assembly, protons within the nucleus aren't exactly hand-holding. They're jostling for space with their positive charge, pushing each other around like kids at recess. Thankfully, the strong nuclear force swoops in to save the day, keeping those feisty protons locked in a tight embrace. This perfect duet of electromagnetism and strong nuclear force gives birth to everything solid. From your sturdy furniture to the luscious air you breathe, it's all due to these unwavering forces keeping matter cohesive. Zooming into the mundane magic of everyday life, electromagnetism becomes a superstar. It's the bartender mixing up the chemical cocktails that create molecules and governs the light we see. Without this captivating force, our universe would be more like an exhibition of invisible ghosts, lots of particles floating around with no rhyme or reason. Instead, thanks to electromagnetism, we have rules of engagement allowing the existence of colorful, tangible worlds with yours truly, sitting at the center of it all. Now, let's bounce up to broader strokes of the universe. The same beautiful force responsible for structuring galaxies is quietly at play, firing signals within your brain. Can you believe it? Those bright neurons sending tiny electric jolts in your head are the same natural phenomena that light up those massive, fiery stars in the sky. When you ponder a thought or feel your heart's enthusiastic beat, electromagnetism is doing its thing. Whether you're pondering the meaning of life or enjoying a quirky cat video. And speaking of sparks of brilliance, let's chat about lightning, nature's own electrifying show. Picture this. A scorching 50,000-degree river of plasma launching from the stormy clouds to kiss the ground, illuminating the night sky like a rock concert. When electric charges accumulate in those dark clouds, they throw a raucous party that eventually becomes irresistible. A brilliant channel of energy bursts forth, sizzling bright enough to steal the thunder from even the fiercest storms. Each majestic bolt of lightning lasts only a fleeting moment, yet it's packing enough power to light up an entire city block. What you see as one stunning strike is often a rapid-fire display of mini discharges, zipping along the same path like the universe's own version of a flashy light show. And let's not forget, even while striking, the temperature often exceeds that of the sun's surface. Nature certainly loves an epic thrill ride. In essence, electromagnetism is the unsung hero weaving together the very fabric of life around us. Whether you're marveling at a glittering night sky, feeling neurons spark during a moment of epiphany, or witnessing lightning electrify the stormy horizon, look closely. This powerful force operates quietly, yet vividly, reminding us just how connected we truly are to everything and everyone across this delightful, dynamic universe. Thunder rumbles across the sky, a dramatic announcement that the very air we breathe is expanding with explosive heat. But it's not just an angry sky, it's the earth flexing its muscle, showcasing the raw power of electromagnetism. Lightning plays the leading role in this natural show, reminding us that electricity isn't just a clever trick invented by humans, but a fundamental force that shapes our atmosphere and grounds the planet's electrifying heartbeat. And speaking of electrical displays, let's not forget about the dazzling northern lights. Those shimmering curtains of green, pink, and violet are Earth's magnetic field pulling off a brilliant magic act. Charged particles from the sun rush toward the poles, colliding with atoms in the upper atmosphere. The result, a mesmerizing light show where each color dances in the sky, courtesy of oxygen and nitrogen reacting to the incoming energy. It's like nature decided to throw a party, and everyone is invited. This spectacle doesn't just dazzle our eyes, it also serves as a powerful reminder that our planet is encased in invisible magnetic fields, constantly in a cosmic tango with solar storms. Without this protective shield, those feisty solar particles might just strip away our atmosphere, leaving us in a rather precarious situation. So, let's raise a toast to beauty that not only captivates but also shelters us from the storm of cosmic chaos. But it doesn't stop there. Oh no, magnetism is a universal player. Picture this, whole galaxies intertwined in a web of magnetic fields, influencing the birth of stars and guiding cosmic rays across the jaws of space. While these magnetic forces may seem weak compared to your kitchen fridge magnet, stretching tens of thousands of light years, they're pulling the strings of the universe in ways we're only beginning to comprehend. Astronomers, those brave cosmic detectives, are on the case, armed with polarized light and radio waves. They map out these faint yet mighty magnetic fields, tracing their elegant twist through spiraling galaxies. Between these colossal structures, they find magnetic connections linking clusters of stars. Who knew that in the vast emptiness of space, there's a silent yet grand design weaving the cosmos together? And of course, let's not sidestep the ultimate diva of our solar system, the Sun. With a magnetic heart that beats in an 11-year rhythm, our fiery friend pulls off an incredible flip every cycle, switching north and south. This magnetic makeover heralds a parade of sunspots, solar flares, and cosmic plasma ejections that can put any fireworks display to shame. Thus, the sun doesn't just light our days. It powers the rhythm of active cosmic phenomena in the wider universe. So, next time you hear the crack of thunder or gaze upon the northern lights, remember you're not just witnessing atmospheric magic, you're observing the grand interconnectedness of magnetism at work. A stunning reminder that beneath the surface of everyday life lies an exhilarating dance of forces shaping every atom of existence. Whether it's the pulse of the auroras or the sun's spectacular flare, the cosmos is alive. And we're all part of this electrifying adventure. During those wild solar times, the sun likes to put on a magnetic fireworks show, where its surface boils and seethes. You can almost imagine it stretching and snapping magnetic lines like a kid with a rubber band, causing chaos in the heavens. But just like any overdramatic performer, the show eventually calms down, the stage gets reset, and the sun is ready for another encore. Surprisingly, all this flare-up doesn't just entertain space. It plays a hefty role on Earth too. Ever wondered how satellites can navigate the vast expanse of space? Well, they are a tip of the hat to the sun's mood swings. Those magnetic fluctuations aren't just there for the drama. They influence everything from the stunning colors of auroras to the relentless solar wind. Picture the sun as a grand conductor, orchestrating a storm of charged particles that fill our solar system like confetti at a parade. Forget your average ball of fire. We've got ourselves a living magnet here. Now, let's talk chemistry and color. The world around you is like a dazzling buffet, all built on one powerful ingredient: electromagnetism. The beautiful colors you see, they're merely the result of specific wavelengths of light being absorbed and bounced around by excited electrons in atoms. And those sweet sounds tickling your ears, while our vibrations transformed into electrifying signals within your nervous system, courtesy of our electromagnetic friend. Ever felt the glorious warmth of sunlight on your skin or the texture of a knitted sweater? Yep, you guessed it. The sensation you experience from touch or smell all boils down to those pesky electromagnetic forces at play. When molecules decide to party together, it's the electrons doing a little rearranging or swapping their orbits. And if you ever forget and try to wander through a solid object, don't worry, electromagnetism has your back, keeping your hand firmly on the right side of reality. But it doesn't stop there. Let's dive deeper into the atomic world. Enter the strong nuclear force, a force so ridiculously powerful, it could lift 1 trillion tons with just a mere teaspoon of its energy. It's the superhero of the atomic nucleus, binding protons and neutrons together like best buddies in a very tight hug. This force is about 100 times stronger than electromagnetism and light years mightier than gravity. If we could bottle it up, we could get rid of all the mountain ranges in a single, magnificent swoop. And how does this powerhouse get its mojo? Meet the gluons, the little particles acting as glue, holding quarks together like a sturdy family. However, the catch is that this strong force only flexes its mighty muscles over the teeniest of distances, less than 1/1,000,000th of a meter. So, while it's busy holding the universe's building blocks tight-knit, it plays a lovely game of hide and seek with anything beyond its tiny domain. It's a spectacle of strength that's both fascinating and fleeting. The strong force, the unsung superhero of the universe that's quietly holding everything together like a cosmic glue. Picture it as the ultimate bond at a family reunion. Everyone's there, bonding and laughing. But good luck trying to pry Aunt Edna away from the casserole. Without this strong force, atoms would rupture faster than a pinata at a kid's birthday party, and we'd be left with a wild mess of radiation roaming free. Talk about a party foul. Now, here's where it gets even crazier. This formidable force actually intensifies when you try to pull apart the protons and neutrons. Imagine rubber bands stretching to their limits while you tug on them. At first, the quarks, the tiny particles within protons, are all chill and relaxed. But the moment you try to separate them, it's like a small panic attack for the universe. Suddenly, it's not just quarks anymore. New quark pairs pop into existence faster than popcorn in a microwave. This quirky quark party is precisely why we've never seen a single quark all on its own. Nature just won't have it. In a valiant display of cosmic unity, nature decided these building blocks of everything must stay together. It's like a stubborn bouncer at a club who refuses to let patrons leave even when they're late for dinner. This nifty quirk is known as confinement. Instead of liberating the quarks, nature tightens its grip, ensuring no atom goes solo. It's as if the universe is sporting a no atoms allowed to mingle sign at a dance hall, keeping the party and matter intact. But wait, there's more. While quarks are technically the heavy hitters, they don't carry the full weight of your mass. If you added up those quirky little particles, you'd find that they contribute only a tiny fraction of what you weigh. The bulk of your mass actually comes from the energy generated by their frenetic ballet inside atomic nuclei. Thanks to Einstein's E=mc², we realize energy and mass are simply two sides of the same coin. Who knew you were walking around with so much energy packed into your very being? When you get down to the nitty-gritty, It's those speedy quarks and their dancing partners, the gluons, racing around in a whirl of energy inside the nucleus that give rise to your physical form. These tiny warriors move so fast, they create kinetic energy that ends up contributing to that nice, solid heft you carry around. It's like your body is a high-speed particle roller coaster, and all you see is the ground beneath you. So go ahead, embrace it. You're not just a sack of bones and meat. You're a bustling city of energy, motion, and connection. The real secret of existence is that what seems like solid matter is actually a magnificent dance of quarks, held together by the mighty strong force. Who knew the fundamental elements of life could come with such an entertaining twist? The strength that binds the universe also crafts your very reality, ensuring that you get to strut your stuff in this particle-packed existence. Inside every proton, a bustling party is happening. Quarks are the VIPs. These tiny particles are like hyperactive toddlers, dancing around in a whirlwind of virtual particles that blink in and out of existence like they're playing peekaboo. Who knew such a simple little thing could be a chaotic swirl, with 3 quarks at its center? The proton is anything but a boring old sphere. It's a dynamic cloud, thriving in a state of energetic frenzy that gives it both mass and stability. Picture this, a sultry summer night, but instead of fireflies, you've got gluons fluttering around, like the best energetic dance partners ever. They're exchanging places, splitting, and recombining in an endless energetic tango. Then you've got quark-antiquark pairs popping out of nowhere, doing their flashy routine for a split second before disappearing into the cosmic void. It's a quantum masquerade ball, keeping everything balanced just right, so right that these protons endure for billions of years, defying the usual lifespan of a party guest. Take a spin outside into the wider universe, where the sun is the ultimate energy factory. Deep within its fiery heart, gravity is playing matchmaker, compressing hydrogen atoms until they just can't resist fusing together. It's a serious romance between forces, where the strong nuclear force swoops in, binding them into helium while shedding a fabulous amount of energy, fueling our very sunbeams. Imagine, every second, the sun's turning 600 million tons of hydrogen into an extravagant energy buffet. Can you say sizzling hot? But wait, this party isn't just solar. Every star winking in the night sky enjoys the same cosmic rave. They're all attending the same event where strength and harmony create a symphony of light and warmth. It's not just about being bright, it's the cosmic heartbeat of the universe, orchestrating a balance that allows beauty to flourish. Talk about celestial elegance. And let's not forget about the shy wallflower of the forces, the weak nuclear force. It might not be the loudest at the dance, but it quietly shifts the rhythm, allowing neutrons to decay and transforming elements into life's essentials. This subtle force turns a stubborn neutron into a proton, an electron, and sneaky neutrinos, ensuring that the universe doesn't freeze into a monotonous sea of hydrogen. Thanks to this unsung hero, stars can create anything from carbon to oxygen, the building blocks of life. The weak force orchestrates a slow, steady burn, controlling the fusion that lasts billions of years. And if you think that's impressive, those neutrinos are racing through space in your very body at an astonishing rate, billions of them dashing around every single second. It's like an invisible parade celebrating cosmic chemistry, proving that even the quietest forces have a loud impact. So, the next time you bask in sunlight or marvel at the stars, remember that the universe is a stage of eternal chaos and creation, where every particle plays its part in a grand, energetic ballet. From the swirling quarks in a proton to the glimmering stars overhead, everything is interlinked in a dance of fantastical proportions, powering the very essence of life as we know it. Isn't quantum physics just the wildest party in existence? Picture this, every atom within your body has participated in a cosmic dance, weaving through the fabric of stars and their incredible life stories. The magic of the weak force is the secret sauce that lets stars simmer like a great stew instead of going kaboom in a cosmic cook-off. If it weren't for this invisible influence, nuclear fusion would occur in a split second rather than gracefully over eons. Let's take our sun, the ultimate stellar comedian, where hydrogen atoms tango through a weak interaction to morph into helium. This slow jam stretches over immense stretches of time, allowing our sun to shine continuously for billions of years. Instead of burning out faster than a firecracker, its steady performance ensures a warm spotlight for planets and potential life to take the stage. Think of the weak force as the universe's cosmic babysitter, maintaining just the right balance for everything to flourish. If it were any stronger, stars would throw tantrums, exploding in wild bursts. On the flip side, if it were too weak, they'd just fizzle out before they even got started talk about a cosmic buzzkill. The precision of these universal forces is why we can bask in the glorious warmth of starlight. Now, hold on to your hats because this weak force is carried by particles more massive than tiny iron atoms. Enter the W and Z bosons. These hefty fellows are about 90 times the weight of a proton, giving heavy lifting a whole new meaning. Their bloated mass means they work best in tiny spaces, less than 1,000th of a proton's width, popping in and out of existence during nuclear reactions faster than you can say subatomic shenanigans. And while they may seem underwhelming compared to their flashier cousins, electromagnetism and the strong force, don't let their name fool you. The weak force isn't weak because it's lacking. It's like a heavyweight champ, held back by the sheer bulk of its carriers. The shocking discovery of these bosons in the shiny 80s proved once and for all why we can frolic in a universe bursting with elements. Imagine if the weak force ceased to exist for a moment. What chaos! Neutrons wouldn't flip into protons, and the cosmos would descend into a monotonous realm dominated by hydrogen. No helium to celebrate with at parties, no carbon for life's building blocks, and oxygen would be as rare as a polite internet comment. Without the gentle ignition provided by the weak force, stars would be toast quite literally, creating a chemically empty universe devoid of all the elements and complexities we cherish. So next time you feel that warm glow from the sun or gaze up at the sparkling stars, remember the unsung hero of the cosmos, the weak force. It's the reason we can enjoy life, chemistry, and the occasional glow of a birthday candle. Cheers to that cosmic regulator, making sure life in the universe isn't just a fleeting flicker but a brilliant, ongoing performance. The weak force is like the universe's secret magician, performing extraordinary feats of alchemy right under our noses. While it may be invisible and can only reach out for a short distance, its presence is felt everywhere, from the fiery centers of stars to the very atoms making up your cozy self. Think about it, every breath you take, every tiny molecule nurturing your body owes its very existence to this force that allows matter to transform. Without it, well, let's just say we wouldn't be having this chat. Now, picture Earth's gravity swaying like a dancer. Sometimes it seems constant, but oh boy, it's got a groove. Each day, the mass of the planet moves subtly, creating a gravitational surge that few notice, as molten magma sneaks under the crust, glaciers throw in their dramatic melt moves, and oceans rise or fall in time with the tides. Earth's mass does the tango. This constant reshuffling means our gravitational pull is as changeable as a weather forecast. High above, satellites are the eavesdroppers of this planetary dance, equipped with fancy sensors to catch the slightest quivers. They help keep tabs on the way ice packs are disappearing at the poles and how our precious groundwater supplies are holding up. They even monitor those heavy rains from the sky. Here's the kicker: gravity, often thought of as the ultimate unyielding force, is alive, responding to the Earth as it continually breathes and evolves. Each step you take is on a field. That's a living, pulsating entity. Now, let's zoom out and talk about gravitational lensing. No, it's not a new dance move, but rather a mind-blowing cosmic phenomenon. Imagine light as a well-trained gymnast, always trying to follow a straight path. But wait, when gravity enters the picture, it bends that light like a roller coaster track. It's like having a massive galaxy cluster pull the strings of light, warping it and directing it our way like a giant lens made of space-time. Thanks to gravitational lensing, astronomers can feast their eyes on galaxies hidden behind splendid cosmic curtains. Without this phenomenon, we'd be clueless about these distant celestial beauties. Sometimes, the light manifests in stunning arcs or perfect rings, magnifying celestial objects that belong to the universe's youth. It's basically the universe shouting, "Surprise, look what I've got for you." So next time you gaze up at the stars, remember that it's not just twinkling lights, there's spectacular science at play. The weak force is an alchemical powerhouse, while gravity dances to an ever-changing beat, and the invisible threads of gravitational lensing bring the hidden wonders of the cosmos right into our field of view. The universe is not just a collection of planets and stars, it's a thrilling symphony of forces, moving and rearranging, eager to show off its grandeur. Peering through cosmic telescopes is like stepping into a time machine that zips back billions of years, unveiling ancient stars and galaxies waving hello from the past. These fascinating tools don't just show us glimmering lights, they also reveal dark matter lurking around. This elusive stuff plays peekaboo with photons, bending light in its gravitational grip. It's as if the universe built its own natural lens, showcasing the artistry of space and time in action. Black holes take this playful light bending to the next level. Imagine light swirling around these cosmic giants in neat, tireless circles. They create a quirky realm called the photon sphere, where gravity is so intense that light can't decide whether to escape or stick around. Picture photons getting dizzy, endlessly circling around a dark void. If you could stand at a safe distance, you'd see the universe's reflections ghosting around the black hole's edges, creating a surreal light show. That's both fascinating and a tad spooky. This photon sphere isn't just any regular old place, it's one of physics' greatest oddities. Here, geometry behaves like that funhouse mirror we all love, curving light in bizarre ways. Thanks to this mind-bending phenomenon, we can witness those glowing rings captured in the breathtaking images from the Event Horizon telescope. That light has been on a wild ride, looping around the black hole so many times that it loses count, showing us just how deep gravity's influence runs. But hold on tight, because the Milky Way is also getting in on the action. Our galaxy doesn't just twinkle with stars and planets, it's a colossal gravitational lens, bending light from galaxies that are unfathomably distant. As light tries to sneak past the Milky Way, the galaxy's massive presence nudges it off course, changing where we think those faraway galaxies might be. Imagine playing an elaborate game of intergalactic hide and seek. The challenge is real, but the rewards are out of this world. For astronomers, the Milky Way's light-bending antics bring both thrills and spills. Yes, the view of ancient galaxies may get a little fuzzy, but it also amplifies the faint ones that would otherwise vanish like socks in a dryer. By fiddling with the distorted views, scientists can get a grip on our galaxy's hidden dark matter halo. It's like untangling a cosmic puzzle wrapped in mystery and intrigue, unveiling the unseen mass that envelops our galaxy. This light warping trickery is like a constant whisper of gravity's influence, reminding us that even here, in our celestial abode, the warping of light occurs over unfathomable distances. So, every time you gaze up at the night sky, remember the universe is not just silent, it's a lively stage where gravity plays a dazzling, invisible game with light, reshaping our view of what's out there in the vast expanse. Every star in our vast Milky Way is like a cosmic performer, participating in a celestial show of gravity and light. It's a mind-bending spectacle that shapes our cosmic view, and you better believe that gravity has the starring role. While other forces may shuffle about or take a timeout, gravity remains relentlessly dedicated. It fearlessly passes through everything, including our attractive, or not so attractive, bodies. This universal nature is precisely why gravity is so compelling and, at times, downright vexing to study. Imagine trying to shield yourself from gravity. Spoiler alert, it doesn't work. You can put a wall in front of you to block light, but good luck finding a gravity-proof material. It simply doesn't exist. Every mass has a magnetic pull, no matter how far apart they are, creating that omnipresent force that stretches across the universe like a friendly neighborhood spider web. It's no wonder that gravity takes charge on large scales, orchestrating the dance of galaxies and the motions of stars, all while intertwining time and space into one continuous cosmic whole. Talk about making a solid entrance. But here's where things get interesting. While gravity is busy pulling everything together, the universe is pulling a cosmic prank by expanding. It's like the universe threw a party, and gravity wasn't even invited. This mysterious, cheeky expansion, called dark energy, is an enigma wrapped in a riddle. Existing even in the emptiest regions of space, it pushes galaxies apart. Stretching space-time faster than gravity can cozy things back together. Truly a celestial tug-of-war. To add to the galaxy-grabbing drama, no one really knows what dark energy is. Is it just a quirky feature of the vacuum of space? Or perhaps an undiscovered field lurking out there, giggling at our best attempts to understand it? What we do know is that this elusive energy dominates the universe, making up about a whopping 70% of all its energy. So, as gravity pulls things in, Dark energy is that rebellious friend who keeps pushing outward, shaping the ultimate fate of everything we hold dear or fear. Now, let's not forget about the magnetic fields, the unseen influences surrounding every star, planet, and galaxy. Wherever there are charged particles hustling and bustling, magnetic fields pop up like surprise party guests. From the molten cores of planets to the fiery plasma of stars, every swirling galaxy joins in on this electric affair. Our Earth's magnetic field is basically Earth's personal bodyguard, protecting it from solar radiation and guiding compass needles like a trusty GPS. Speaking of the Sun, its magnetic field throws some serious shade, driving cycles of flares and storms that can affect everything from our communications to that fantastic light show we call the auroras. The universe is full of drama, and every magnetic field plays its part, creating the grand cosmic ballet. So, next time you gaze up at the stars, remember, they're not just floating around aimlessly, they're caught in a never-ending cosmic dance, shaped by gravity, dark energy, and magnetic flare. Even in the vast expanses of interstellar space, invisible magnetic fields dart around like cosmic spiders weaving intricate webs between the stars. These magnetic forces don't just lounge idly, they play a crucial role in the birth of new suns. Though they elude the naked eye, their influence can be detected through the magical way they polarize light. Talk about cosmic craftsmanship. These galactic strands reach out for tens of thousands of light years, dancing together with stars in a grand celestial ballet. Now, magnetism might seem like just a nifty trick we see in the fridge, but it turns out it's one of the universe's superstar phenomena. Imagine it uniting the tiniest particles of plasma with a majestic motion of entire galaxies. Wow! These forces span scales that differ by trillions upon trillions of times. Even the vacuum of space isn't as empty as it seems. It carries magnetic energy that stretches across nothingness, defying every notion of blank space we've ever known. And when these magnetic fields change, watch out. They generate electric fields and keep their pizzazz even in a seemingly barren vacuum. Just picture vast magnetic lines curving through the void, holding onto energy and acting like bumbling conductors for charged particles wandering about. It's like a cosmic game of hide and seek, especially during solar storms when Earth's magnetic forces throw a wild dance party, sending radiation bursts that could crash satellites and cause chaos in power grids. The air between stars is bustling with magnetic energy influence, molding cosmic plasma and fueling the evolution of galaxies. Even those tiny quantum fluctuations that you'd think would go unnoticed can spark magnetic effects. Yep, that seemingly empty vacuum is actually a lively little place, resonating with invisible motion from one cosmic horizon to another, buzzing with magnetic fields that spin tales unknown to most. But here on Earth, we, too, are magnetic beings. Every single heartbeat creates a dainty magnetic field that can be detected from a few centimeters away. As the heart muscles contract through electrical impulses, they emit a gentle wave of energy, almost like a soft whisper of life. Specialized tools called magnetocardiograms can pick up these faint fields, allowing us to appreciate the rhythm of our life force. Isn't that just heartwarmingly cool? And don't think we're just limited to our hearts. Our brains are buzzing with activity too, with neurons firing like energetic little fireflies. They create an electric current whose patterns can translate into detectable magnetic signals. Scientists are practically like modern-day wizards, mapping emotions and thoughts through these magnetic signatures. We're not just corporeal beings, we're walking bundles of magnetic magic, responding to the universe in ways we're only beginning to understand. So, the next time you stare up at the night sky, remember that everything around us, be it stars, galaxies, or our very own hearts, is tethered by a spectacular web of magnetism. This crazy cosmic game connects us all, proving we are not alone in the universe. So, let's embrace our inner magnets and dance along with the stars. Every organ in our body that runs on electricity, from the pulsing heart to zippy nerves, creates little ripples in the electromagnetic field around us. It's like the universe as a personal playlist, connecting the grand forces at play in the cosmos to our own squishy, living selves. Honestly, who knew the laws forming galaxies were also softly jamming within us? It's like having your own cosmic DJ spinning unseen vibes day and night. Now, think about the sun. It's not just glowing away up there. It's a tempest of boiling plasma tangled in magnetic lines doing the CHR. Occasionally, these magnetic loops get so worked up that they snap and dance apart in a fiery explosion called a solar flare. Imagine this. Within minutes, a flare can unleash energy equivalent to billions of nuclear bombs. Talk about a cosmic party trick. And when those charged particles take a joyride to Earth, they can turn our tech upside down and gift us with those epic polar lights. Those beautiful auroras, yeah, those dazzling ribbons in the sky owe their existence to the omnipotent solar flares. When solar flares and coronal mass ejections fling energetic particles toward Earth, they dive down along our magnetic field lines, crashing into atmospheric gases near the poles. They literally light up the sky as oxygen and nitrogen get all jazzed up, radiating beautiful colors reminiscent of an artist's palette. It's like the universe decided we needed a little spectacle to spice up our dark nights. Oh, and let's not overlook how these glowing wonders can sneak far beyond the poles, gracing areas that don't usually get in on the action. From the ground, these lights seem lovely and peaceful, but really, they are the bright side of a global electromagnetic tempest. They serve as a cheeky reminder that our planet doesn't float alone, it's tethered to the magnetic power of its fiery sun, having a wild time above us. Now, let's take a trip inside our very own atoms, where the real magic happens. The strong force, which is the glue holding our world together, is delivered by these quirky particles known as gluons. Picture gluons as the busy maids of the atomic world, tidying up every proton and neutron by binding quarks like a pro. With names like that, they've got to be good, right? They zap between quarks, keeping a balance of color charge, which is essentially the secret source of the strong force. In fact, gluons make sure those quarks don't throw a fit and fall out of line while they're busy making everything we see or can't see. They're like that friend who makes sure nobody leaves the party without a good time. Isn't it wild to think that even down at the tiniest scale, there's a whole party going on? So, while we enjoy our earthly experiences up top, there's a raucous dance of particles happening deep within, orchestrating the grand harmony of existence. All of this swirling energy, from the sun's extreme outbursts to the microscopic bonding of quarks, reminds us we're all part of something bigger. It's like being connected through an invisible web of chaotic beauty, linking us to the universe at large. So, the next time you gaze at the auroras or marvel at nature, remember the electric life buzzing within you. It's not just life, it's a cosmic dance. Imagine a bustling city of quarks, where every corner is filled with the buzzing energy generated by gluons, the social butterflies of subatomic particles. Unlike photons, which just float around minding their own business, gluons prefer to mingle, creating a tangled web of connections that keeps everything intact. This invisible network is so strong that it's nearly impossible to find a lone quark, kind of like spotting a unicorn at a busy intersection. When one quark decides to take a little jaunt, the gluons spring into action, adjusting their energy and spreading the load like expert jugglers at a fair. If you think pulling one quark away is easy, think again. The moment a quark tries to break free, the strong force charges up like an overprotective bouncer, pushing back with a force that builds an exciting crescendo. If you persist, the energy surges so high that it magically converts into new quark-antiquark pairs, ensuring you've got double the trouble instead. Quarks prefer to huddle together, typically forming trios within protons and neutrons or cozy pairs called mesons. This quark confinement forms a fascinating tapestry for the strong force. It's like a perpetual group project that will never let anyone break away. What seems like a restrictive boundary is truly a blessing. Without this confinement, atoms would crumble and our universe would resemble a cosmic free-for-all. Thank goodness for this unbreakable pact that keeps matter intact. The next time you admire the solidity of an atom, remember it's the strong force playing hide and seek under the surface. A single proton, tiny as it is, carries a mind-boggling amount of energy, all thanks to the frenetic dance of quarks and gluons. Scientists often find that the quarks themselves barely contribute to the proton's mass. It's the energy from their rapid movements and their bond with gluons that adds the heft. Who knew that such tiny particles could pack such a punch? While quarks are almost negligible in weight, their speed is out of this world. They're zipping around at near light speeds within the cramped quarters of a proton, creating a racing current of kinetic energy. It's this swirling dynamism, vastly more important than their mass, which gives protons their significance in the cosmic scale of things. It's like those super fast squirrels you see darting around in the park, all energy and barely any weight. So, next time someone tells you to take things slowly, remind them of the quarks inside a proton, who have no time for a leisurely stroll. They bounce around the atomic realm with a zest that turns sheer motion into an explosive force of nature. That's right, those little guys are packed into every atom of your body, making sure that you stay solid, grounded, and full of life, bringing wit and whimsy to the very fabric of reality. Einstein got it right when he suggested that energy and mass are basically two sides of the same coin. Take protons, for instance. They aren't just sitting around looking pretty. They're like energetic whirlpools colliding with themselves, constantly swirling in a dramatic dance of energy bound by gravity and other forces. Every atom that makes up your body, and every speck of matter around you, comes from this chaotic energy show a motion condensed into what we call permanence. Isn't that mind-blowing? Now, let's talk about neutron stars. They're like the heavyweight champions of the universe, sustaining themselves against the relentless punch of gravity. Picture this: a massive star exhausts its fuel, and its core crumbles under gravity's oppressive hug. In a stunning cosmic twist, protons and electrons merge to form neutrons, which then band together tighter than a family that's just survived a reality TV show, and voila, a neutron star emerges, compact yet heavier than the sun, all crammed into a sphere that's barely 20 kilometers wide. Talk about a weighty situation. If you think a neutron star size is wild, wait till you hear about its density. A single teaspoon of this stellar wonder could weigh billions of tons. Now that's what I call heavy lifting. Inside these celestial gems, gravity presses inward with unthinkable force, while the powerful, strong nuclear force fights against it like a superhero trying to save the day. This cosmic tug-o-war results in a perfectly balanced structure, with attraction and repulsion locked in an eternal struggle, creating the universe's most compact form of matter. On the outside, neutron stars emit a glow filled with trapped radiation and fierce magnetic fields, remnants of the epic battle waging within. Imagine a cosmic light show. This glow is crucial. Without it, we'd have chaos, every atom destined to explode due to electrical repulsion. A real party pooper situation. Inside atomic nuclei, protons, all carrying a positive charge, are like a bunch of shy kids at a dance, refusing to get too close because of that pesky repulsion. But fear not, a strong force steps in like the ultimate party planner, binding those protons together in a way that defies logic. It's a cosmic glue, overpowering electrical push between protons at tiny distances, ensuring the nucleus stays intact even when dozens of the hefty protons are squished together like sardines. It's this robust force that keeps atoms stable and balanced, turning what could be chaos into harmonious existence. Let's get this straight. The strong nuclear force is a heavyweight champion, overpowering electromagnetic repulsion by a whopping factor of 100. But here's the kicker: its power only stretches over distances smaller than a proton. This tiny but mighty reach helps define the very fabric of matter, striking a gripping balance between attraction and repulsion. Without it, you better believe solid objects would just fly apart, leaving us with a boring sea of charged particles. Talk about a cosmic mess. The quirky nature of the weak force has physicists scratching their heads. As it turns out, this force isn't keen on symmetry. Unlike most physical laws that treat left and right as equals, the weak nuclear force has a clear favorite: left-handed particles. Can you imagine? It's like being at a party where one side of the room is devoted to left-handed fun while the right-handed revelers are left out in the cold. Discovered in the 1950s. This unexpected bias defied the old belief that nature plays fair, revealing that, in reality, the universe has a bit of a personality. In a rather shocking twist worthy of a sci-fi plot, this preferential treatment is evident in radioactive decay and neutrinos, which strut through the universe with a permanent left-handed flair. Why does the weak force choose sides? Well, the answer remains a celestial mystery, but the consequences are nothing short of groundbreaking. This subtle imbalance between left and right might just be the secret sauce that allows matter to exist at all, a quirky twist in the cosmic code that impacts everything we know. Think back to the nascent moments after the Big Bang, an explosive event that birthed both matter and antimatter in nearly equal rave-worthy quantities. When these messy dance partners collided, they annihilated each other, turning into pure energy. Yet, amidst the cosmic chaos, a tiny portion of matter managed to stick around. Here's where the weak force enters the spotlight. It's somehow discriminated during certain interactions, giving matter the chance to survive the grand cosmic cleanup. That surviving sliver became the foundation for everything we see in the universe today. Without this minuscule preference for matter, the universe would have been an empty realm, hardly the vibrant space buzzing with life that we know. Forget galaxies, stars, and planets. We would be left with nothing but photons zipping around. The fact that you're reading this is thanks to a subtle quirk of the weak force, a tiny bias written into the universe's earliest equations, which delivered us all from photon-only purgatory. So, how exactly does the weak force shape our universe? It's a silent architect, deftly sculpting the chemical diversity that defines existence. While strong and electromagnetic forces provide the robust framework for matter, the weak force takes on the role of the cosmic artist, molding atoms at the heart of stars. It's in those stellar workshops where protons morph into neutrons, dictating which elements strut into existence and how abundant they become. This powerhouse of a force also controls the rhythm of nuclear fusion and influences the lifetimes of stars. Imagine a dance floor where the weak force calls the shots, ensuring that stars don't just twinkle forever as bland hydrogen balls, but rather develop into dynamic entities capable of creating the building blocks for planets and, ultimately, life itself. The weak force operates like a stealthy ninja, silently shaping the very fabric of chemistry without a hint of flash or drama. Its impact is immeasurable and fundamental, ensuring that the universe doesn't remain in a monotonous hydrogen freeze. Instead, it orchestrates a grand symphony of elements, all thanks to that tiny twist of fate, a preference for the left, who knew the universe had such an amusing and eccentric side. Every atom heavier than hydrogen was sculpted by a quiet cosmic artist. The neutrino. These tiny particles are like the friendly ghosts of the universe, nonchalantly zipping through everything, including you. Picture it, billions of neutrinos are streaming through your body every single second, passing through walls, furniture, and even your morning coffee without batting an eye. They're so chill about their existence that they barely interact with anything, behaving like the ultimate introverts of the cosmos. Neutrinos are born in explosive nuclear reactions, think supernovae and the Big Bang. They're the universe's secret agents, constantly delivering information from those monumental cosmic events. But, thanks to their weak force interactions, neutrinos are practically invisible. They travel through solid rock, entire planets, and, oh yes, you without a care in the world, almost like a cosmic joke. Most of the billions produced by the sun each second breeze through Earth as if it's just a cozy stroll in the park. To catch a glimpse of these elusive particles, scientists embark on a quest for their rare encounters. They set up massive detectors, like giant, subterranean balloons, filled with water or ice. These high-tech hideouts are shielded from all other types of radiation. Every once in a while, a neutrino will sneak in and collide with an atom, creating a faint flash of light. Imagine the excitement. It's like spotting Bigfoot, rare but totally mind-blowing. Through these rare flashes, neutrinos tell tales of cosmic drama, from the fiery births of galaxies to the final acts of dying stars. They are like the universe's messengers, effortlessly weaving through the fabric of space and time. With their remarkable ability to pierce through anything, they offer glimpses into events that even the most powerful telescopes can't see. Talk about having the ultimate backstage pass to the universe's greatest hits. Enter Einstein, the heavyweight champ of physics, whose general theory of relativity literally reshaped our understanding of the cosmos. According to him, gravity isn't just a mysterious force pulling things together. It's all about mass and energy curving space-time. Imagine space-time as a giant trampoline, where heavy objects bend the fabric, creating a slide for smaller ones. That's gravity throwing a curveball to our perception of reality. The wild part, time itself bends around massive objects. In areas with heavy gravitational influence, clocks tick a tad slower compared to those floating far away. It's time travel, but only in the sense that time behaves differently in different cosmic neighborhoods. So while you're sipping your coffee and reading this, somewhere in the universe, time is moving to its own quirky rhythm, all thanks to gravity's magic. In this cosmic comedy filled with silent travelers like neutrinos and the bending of time, we are reminded of how zany and intricate the universe is. It's like an interstellar circus where particles and gravity perform their complicated dance. So next time you feel insignificant in this vast cosmos, remember, trillions of tiny messengers are flying through your world, continually shaping the story of existence. One ghostly interaction at a time. On Earth, gravity has its quirks, but with advancements in technology, we can measure its effects every day. Our trusty GPS satellites require subtle adjustments to keep their timing accurate, ensuring we don't end up in the wrong part of town or even worse, lost in space. However, if you think gravity is just about keeping us on the ground, think again. Near a black hole, time behaves like that friend who just won't stop talking. It practically freezes. Imagine a scenario involving a spacecraft bravely flying toward a black hole. As it approaches the infamous event horizon, its signals transform, stretching into mesmerizing but slow pulses of light. To an observer standing far away, it's like watching a movie that suddenly changes genres. The spacecraft appears suspended in time. Its signals fade to an alluring dulcet red until they finally vanish into the abyss. Yet inside the spacecraft, time carries on as usual. The passengers don't toss. They're snacks in the air waiting for an arresting moment. This curious juxtaposition of time is the crux of Einstein's relativity. For folks observing from afar, time appears to hit the brakes, while those inside the black hole experience a straight shot toward a singularity, where all journeys ultimately converge. The event horizon isn't just a door, it's where time itself seems to take a breather. So, your timing can vary greatly depending on where you find yourself in the cosmic dance. Talk about a cosmic identity crisis. Now, let's shift gears from black holes to the old-school understanding of gravity. For centuries, Isaac Newton held a crown, explaining gravity as an attractive force that kept objects, including apples and planets, bound together with a predictable pull. However, Newton had his reservations about this instantaneous force acting faster than light, and honestly, who wouldn't? Enter Einstein, swooping in with the revelation that gravity isn't really a force at all. Instead of thinking of gravity as a magical force field, Einstein proposed a wild twist. Gravity is actually geometry. Imagine space-time as this luxurious space carpet, where masses like planets and stars tell it how to curve. As that carpet bends, objects roll along its grooves. Planets whip around stars following what are called geodesics, the smoothest paths through this warped reality. Light, despite having no mass, gets swept up too, bending around massive bodies just like a marble tracing a path on a curved surface. With this revolutionary perspective, the notion of a force disappears into thin air. Gravity becomes a dance of shape, flow, and warp. No hidden hands pulling at celestial objects. Instead, the great cosmic ballet unfolds as planets glide and twirl along the curved pathways shaped by surrounding masses. So, next time you gaze at the stars or try to decipher the great cosmic puzzle, remember, we're all just marbles rolling on a fascinatingly warped cosmic carpet. And time, well, it's just along for the ride. The Earth, contrary to popular belief, doesn't just get yanked into the sun's orbit like a celestial yo-yo. Instead, it floats around in a kind of cosmic dance amid a cleverly bent fabric known as space-time. Think of space-time as a warped sheet stretched by the heavy sun, making it curve just enough for the Earth to cruise around it. So, while we might feel like we're being tugged, we're actually gliding along the curves of this cosmic highway. And it's a pretty smooth ride. This orbital motion isn't some cumbersome workout for Earth. It's like enjoying the effortless drift in a whirlpool, floating along the geometric waves. It's a continuous free fall through curved space that never ends, with the ground, or the curved space-time, beneath us always doing its cosmic wiggle. Even our beloved moon is caught up in this elegant motion, swirling around Earth as it follows the same unwritten dance rules set by the laws of physics. Planets, asteroids, and comets join in this graceful ballet across the universe. They don't haul themselves along through brute force, but glide along the natural paths dictated by the warping of space caused by massive bodies. If, by some cosmic magic, the sun vanished, space-time wouldn't just chill. It would flatten out instantly. Earth would stop its graceful pirouette and drift off in a straight line, forever alone in the endless void. Now that's some cosmic heartbreak right there. This delightful realization puts a whole new spin on our understanding of gravity. No longer a mysterious tug-of-war between celestial bodies. gravity transforms into a beautiful choreography of motion that reflects how space twists around mass and energy. Each planet weaves a dance through the sculpted fabric of reality made by its star, confirming the truth that gravity is an art form as much as a science. The relationship between a planet and its star isn't arbitrary magic, it's a delicate balance, like an artist balancing their colors. A planet closer to its star cradles itself deeper in the gravitational well, racing around like it's got somewhere to be. But farther out, the worries ease off, and the pace slows down as the cosmic asphalt flattens out. It's this harmonious balance that ties together the beautiful symphony of our solar system. Just think of it as cosmic architecture holding everything in place. Even the quirks of a planet's spin or the irregular wobble in its orbit tell us the hidden secrets of spacetime's layout around its host star. This cosmic masterpiece connects everything from the tiniest moon to grand galaxies, weaving an intricate tale of inevitability rather than mere effort. The magnificence of gravity dazzles us with its order, where every orbit is a smooth response to the dance of the universe itself. Talk about being in perfect rhythm. Now, let's not forget about light while we're at it. The electromagnetic spectrum is not just a rainbow for the eye, but a wild mix of waves. From friendly radio waves to the dangerous gamma rays, our eyes can only perceive a tiny slice of this spectrum. But light is a dazzling display of varied wavelengths and energy levels, creating an ongoing spectacle beyond our imagination. So while we bop along in our cosmic dance, light is out there, showcasing its elegance in ways we are only beginning to comprehend. The electromagnetic spectrum is nothing short of a cosmic menu filled with delectable frequencies. At one end, we have those languorous radio waves, stretching out for kilometers like a lazy cat napping in the sun. They carry whispers from the cosmos and allow you to listen to your favorite tunes while driving. Next up, the vibrant microwaves, not just for reheating yesterday's pizza, but also busy deciding tomorrow's weather forecast. Talk about multitasking. Infrared radiation joins the party, revealing warmth like an affectionate hug from the sun. It's perfect for those chilly evenings when you're trying to figure out where your blanket went. Then there's visible light, the vibrant painter of our world, splashing colors onto everything from the colorful flowers blooming in spring to that sassy sunset, making you question if life is indeed as artistic as it seems. Nature surely knows how to turn on the charm. And lurking beyond the visible spectrum are ultraviolet rays, those sneaky little troublemakers that deliver a dose of invisible energy capable of turning your blissful day at the beach into a sunburn disaster. X-rays come to the rescue, slipping through your flesh to reveal the hidden treasures, your bones. They're like the nosy relatives of the electromagnetic family, eager to learn more about you but in the least invasive way possible. Let's not forget the superheroes of the spectrum, gamma rays, emerging from explosive supernovae and black holes. These mighty waves wield enough power to split atoms and even tinker with DNA. All these waves, from the mellow radio signals to the explosive gamma bursts, are actually just different notes on the same energetic tune, vibrating at different speeds. They may look different, but they're all part of one gigantic cosmic concert. Every oscillation in the electromagnetic spectrum moves at the speed of light, reminding us just how fast this vibrant party gets. It's like a cosmic dance, where frequency dictates the behavior, long waves for radio, flashy ones for lights, and those intimidating high-frequency waves for X-rays and gamma rays, all moving swiftly through space, connected in a grand physics relay. Who knew the universe had such a funky nightlife? In an electrifying twist, changing magnetic fields do a little dance with electricity, creating a beautiful love story between the two. When electric charges shimmy around, they produce magnetic fields. And if those magnetic fields decide to shift, hello electric currents. This dynamic duo, discovered by Faraday and explained by Maxwell, forms the backbone of our modern gadget-filled life. It's like a high-tech tango, with power plants spinning magnets to create electricity and electric motors, giving those fantastic spins back into motion. To top it all off, light itself is essentially an electromagnetic wave, like a self-sustaining party where electric and magnetic fields take turns creating one another. It's a symphony that connects everything from your buzzing smartphone to the dazzling displays of distant galaxies, with one overarching rhythm. The universe is speaking a universal electromagnetic language, an endless dialogue of energy, making everything in existence remarkably connected. Every time you flip a switch, charge your phone, or bask in warm sunlight, you're immersed in a phenomenon that's akin to a cosmic dance. This endless feedback loop is the powerhouse of our world, converting invisible motion into the electricity zipping through your gadgets. It's not just magic, it's a captivating relationship driving every generator on Earth. The seamless conversion of kinetic energy into electrical energy is like watching a magician pull a rabbit from a hat, only the rabbit is lighting up your home. Let's break down the generator game. Picture coils of wire spinning inside magnets, or magnets spinning around wire, expertly stirring the pot of magnetic enchantment. This merry swirl creates a constantly shifting magnetic environment, which, like a sudden plot twist in your favorite movie, induces electric current. Thanks to this thrilling motion, every watt illuminating our cities or energizing our devices emerges. From the mighty turbines at hydroelectric dams to those mini alternators zooming in your car, they're all part of this interactive spectacle. Now, let's take a detour into the world of superconductors, the rock stars of physics. These cool dudes can expel magnetic fields completely when cooled to near absolute zero. Imagine a concert where the band defies gravity. In this superconducting state, electrical resistance hits the snooze button, vanishing into thin air. This phenomenal effect, known as the Meissner effect, allows magnets to float gloriously above superconductors, held aloft by invisible magnetic strings, creating a spectacle more entrancing than a magician's finale. The current within these superconductors flows with the grace of a ballet dancer, ceaselessly spinning without losing energy. Picture this as the ultimate electrical loop, theoretically capable of lasting forever. This mind-blowing discovery opened the floodgates to futuristic wonders like magnetic levitation trains, quantum computers, and powerful particle accelerators. It's as if nature itself whispered its secrets, revealing a harmonious dance of matter and magnetism, where everything flows effortlessly. But wait, there's more. Let's not forget the strong nuclear force, nature's superhero. It's that incredible glue holding atomic nuclei together, ensuring the universe doesn't fall apart at the seams. Yet, this powerful force can also ditch the glue and tear them apart during moments of fusion. Imagine it as the ultimate plot twist. One moment it's all about unity, and the next, it's a jaw-dropping explosion of energy when stars collide. In this grand performance of energy, we see the intricate ballet of physics knitting our reality together. As you switch on that lamp tonight or feel that gentle breeze from an electric fan, remember the profound interactions happening behind the scenes. It's a world where motion meets magnetism, fueling our civilization in a spectacular show of scientific brilliance. Nature has truly woven an elaborate story of energy that not only lights up our lives but encapsulates the essence of the cosmos. Imagine a bustling party happening inside every atomic nucleus, where protons and neutrons are tightly bound like dance partners clinging to one another. It's so crowded that separating them requires a colossal amount of energy, akin to trying to pry a toddler away from their favorite toy. But here's the twist: under extreme conditions, instead of getting tuckered out, the strong force can actually throw a wild energy-filled celebration, releasing light and heat as a byproduct of fusion. In the dazzling heart of our sun, hydrogen nuclei run around in an energetic frenzy, zipping and zooming until they finally collide and fuse into helium. It's like a cosmic game of bumper cars. This high-speed mingling releases a burst of energy that escapes into space, showering us with warmth and light. Meanwhile, when the party gets too rowdy and heavy nuclei split apart via fission, they release even more energy, reminiscent of launching fireworks to celebrate at the end of a night that just got too crazy. Every time you feel the sun's warm embrace or glimpse a nuclear reactor humming away, think about that same wild atomic soiree. Both fusion and fission harness that same relentless strong force, using Einstein's magic equation, E equals mc squared, to convert mass into energy. It's a bit like flipping a switch, letting matter transform into something truly spectacular. The stars, after all, live off this eternal dance that fuels their brilliance. Now, let's look at the sun's core, where temperatures soar beyond 15 million degrees Celsius, a blazing inferno where hydrogen atoms dance like they're at the hottest club in the universe. With all that energy, they can shake off their natural reluctance and collide with one another, creating helium and sending out a flurry of energy in all directions. It's not just party vibes, it's essential for life on Earth. reminding us that we're all connected by the nuances of these atomic shenanigans. Back on Earth, we've tapped into this dazzling cosmic force in our power plants. By splitting heavy atoms like uranium, we release the energy tightly packed in their atomic bonds. It's like opening a highly coveted treasure chest filled with shimmering goodies, except instead of gold, it's pure energy ready to light up our lives. Here, the strong force is the life of the party, making things happen in both explosive and peaceful ways. Scientists are even attempting to replicate this fantastic fusion process in labs, hoping to unlock clean and nearly limitless energy sources. It's a bit like trying to bottle up sunshine for the cloudy days. They're juggling protons and neutrons in hopes of harnessing that incredible force in a way that will power the future. Just think, your sun-kissed skin and the energy powering your devices both owe a nod to this molecular revelry. All this might be happening at a level smaller than the tiniest speck we can imagine. The strong force does its magic in distances even less than a trillionth of a meter of space, so small it's hard to fathom. Yes, it's powerful, but it's also a delicate little phenomenon, acting only in the subatomic realm. It's like a shy yet mighty guest who prefers to remain behind the scenes, quietly transforming our world in remarkable ways while we enjoy the party at a grander scale. In the cosmic playground where the strong force reigns, it only showcases its might across a tiny distance. Beyond this short span, it totally bows out, creating a semblance of stability in an otherwise chaotic universe. Picture nuclear clusters collapsing under extreme pressure without this tiny reach. But, within its borders, it sparks wild interactions. Quarks tango together, forming protons and neutrons, which then unite into atomic nuclei. This magical balance is what keeps matter from going bonkers. Enter the hero of the strong force, gluons. Unlike their shy counterpart photons, gluons are extroverted and carry a unique color charge. Imagine them as colorful little messengers, weaving through quarks and binding them inside protons and neutrons. This makes things spicy and self-referential, as they engage in a lively dance. Gluons also create quite the energetic ruckus. Inside each proton, there's an ongoing party, with gluons constantly splitting, merging, and creating a storm of energy. That keeps quarks tethered together, never allowing any of them to vacation solo. But here's the kicker: while this chaos could seem a bit overwhelming, it's actually the foundation of our existence. It's an energizing paradox. Out of these frenetic frolics within protons springs the calm and sturdy structure of matter. Isn't it wild? All this rabble leads to almost all the visible mass we see around us. The quirks of gluon interactions hold the secrets to the universe's stability, proving that chaos and order can live together in harmony. Now, let's turn our attention to the unsung hero of stellar operations, the weak force. It may not have the glory of gravity or the bite of the strong force, but it's the quiet craftsman in the background, making magic happen in stars. This force is essential for transforming particles, flipping protons into neutrons like a magician pulls a rabbit from a hat. It fuels the chain reactions necessary for stars to keep burning and shining, enabling them to create crucial elements for life. Without the weak force working its magic, we'd be left with a periodic table that stops at helium. Can you imagine a universe starved of carbon, nitrogen, and oxygen? Ridiculous, right? This humble force lays the groundwork for the ingredients of life, allowing stars to create heavier elements through fusion. So, here's to the unsung hero that enables the cosmic kitchen to whip up the stellar ingredients we need. In a universe filled with heavyweights like gravity and the strong force, the weak force brings a unique flair of its own. It plays a fundamental role in stellar nucleosynthesis, weaving through supernovae and stellar cores, ensuring that elements like carbon and oxygen come into existence. If the strong force is a raucous party, the weak force is the deft chef, quietly stirring together the essentials for life's recipe. So, let's give a shout out to both the strong and weak forces. Together they orchestrate the cosmic ballet of creation and stability. In the grand scheme of the universe, even the smallest forces can wield unimaginable power, crafting the majestic tapestry of existence itself. Who knew the secrets to life were buried deep within the particles that make up our atomic souls? It's an electrically charged dance party at the smallest scale, one that holds the universe together. In the heart of dying stars, the weak nuclear force kicks into high gear, leading to dramatic supernova explosions that fling elements across the cosmos like confetti at a space party. Every deep breath of oxygen you inhale and every little carbon atom buzzing in your body are thanks to these stellar fireworks. Sure, the weak force seems like a small-scale player in the universe's game, but its reach is cosmic, shaping the very fabric of matter and making existence possible. Without it, you'd be a puff of hydrogen floating aimlessly, a real cosmic bummer. Speaking of bummers, can you imagine a universe where hydrogen just hangs around, forever unable to fuse into heavier elements? Yikes, stars would never ignite, leaving the cosmos colder than a fridge in an Arctic winter. Thanks to the weak force, we enjoy a delightful concoction of elements. It drives radioactive decay and that special beta brunch we didn't know we needed, giving birth to stable isotopes, and letting essential elements like carbon, oxygen, and iron strut their stuff in the universe. And there's more. Even right now, traces of the weak force are working their magic beneath our feet. They keep Earth's interior toasty, igniting volcanic eruptions and maintaining our planet's fabulous magnetic field. This force might be stealthy and delicate, but it's like the universe's behind-the-scenes director, sculpting the tiny details that go into the very fibers of our existence. Every atom whizzing around in your body was once part of a star that blinked out of existence long before our own sun took center stage. Switching gears, let's talk about gravity and electromagnetism, our universe's cosmic duo. Gravity is the strong, silent type that pulls everything together into dramatic cosmic structures. It ropes in matter to form stars, and then compels those stars to gather into galaxies. Sure, gravity gives the universe its shape, but without electromagnetism, it'd be nothing more than a dark, cold void, a real snooze fest. Electromagnetism is the life of the party, adding sparkle and shine as energy from fusion bursts forth, lighting up the universe with radiant energy. Picture this: magnetic fields dancing through galaxies like a cosmic ballet. They influence plasma flows, guide star formation, and create energetic jets that stream for light years. When you see the Milky Way twinkling overhead, it's a stunning reminder of how gravity and electromagnetism work together. They create a cosmic symphony, blending attraction and brilliance into a picture-perfect harmony of celestial beauty. Let's not forget about the strong and weak forces bearing down on us from within those fantastic stars. They build every nucleus, ensuring that everything from the oxygen in our lungs to the iron in our blood gets a ticket to the great elemental show. Each tiny atom's journey is a testament to these forces, working tirelessly to ensure we live in a universe bursting with diversity and vibrant life. Without them, we'd be left staring at a blank canvas. So here we are, living our lives, blissfully unaware of the astonishing forces lurking just beneath the surface. Thanks to these invisible players, the strong, weak, gravity, and electromagnetic forces, our universe isn't just a collection of atoms and stars. It's a sprawling playground of complexity and wonder. Sometimes, it's worth taking a moment to appreciate the cosmic teamwork that made all this possible, and remember, we're all made from stardust. In the grand cosmic theater, two stealthy forces are the true MVPs of the universe: the strong nuclear force and the weak force. Picture them in a tandem dance, like partners at a heavenly ball, where one sticks protons and neutrons together in a fierce grip while the other pulls off tricks that help create new elements. They're behind the scenes orchestrating the birth of every atom heavier than hydrogen, including all the bits and pieces that make up you, your cozy couch, and that oddly satisfying slice of pizza. Now, let's notice how these forces decide everything from whether a star flickers out as a placid white dwarf or erupts in a dazzling supernova. Imagine them like a cosmic tug of war, one pulling together, the other letting things shift around to make new atomic buddies. It's in this delicate balance between the two that the destiny of the stars unfolds, with universes breathing in and out, accordion style, filling empty spaces with moments of wonder and chaos. Zooming into the tiniest levels, these forces have the uncanny knack to set the rules on how atoms strut their stuff, while on the grand scale, they're the masterminds behind the majestic ballet of galaxies swirling through space. It's mind-boggling to think that within every cell in your body, the strong and weak forces are dutifully at work, weaving the intricate fabric of existence. One nucleus at a time, sort of like cosmic seamstresses meticulously stitching up the universe. But wait, there's more. When you combine the strong and weak forces with their pals gravity and electromagnetism, you get a stellar quartet defining reality itself. Each force plays its own unique tune. Gravity gathers celestial bodies into sprawling clusters, while electromagnetism shapes the dance of atoms, ignites light, and fuels the chemistry that makes your morning coffee just perfect. Together, they create the incredible tapestry of all motion, structure, and experience. Every breath you draw and every twinkling star you spot is a fleeting note played in the grand symphony of these four fundamental forces. It's like a pompous orchestra, where each instrument relies on the others, yet shines brightly in its unique spotlight. If one of them were even a smidge off-key, the universe could face a cataclysmic catastrophe, collapsing, burning, or disappearing before our very eyes. Now, let's focus on a character in the mix, gravity. This fellow is a flabbergasting paradox around 1,000 billion times weaker than the strong force. It sounds slightly absurd that this meek player holds the entire universe in its cozy embrace. The gravitational pull between two protons is so tiny that it's virtually invisible next to the mighty strong force. Yet, here's the kicker. Gravity is that steadfast friend who never walks away. It's always tugging, never cancelling itself out, and its whispers grow louder as cosmic bodies gather together. So, while the strong force may be flexing its muscles, gravity quietly plays the long game, orchestrating the grand design we call the universe. So next time you look up at the night sky, remember, it's not just twinkling lights you see, but an exquisite performance of forces holding it all together, an elemental buddy system that makes cosmic wonders possible, one delightful twist at a time. Gravity, the ultimate heavyweight champion of the cosmos, plays an astounding role despite being the weakest of nature's four forces. While electromagnetism plays the game of attraction and repulsion, gravity has a singular mission: to pull everything toward itself. It's like that friend who always hogs the spotlight during karaoke. Their attraction is undeniable, and nothing can dilute their force, thanks to gravity's never-ending pull. Stars, galaxies, and even planets can exist. Imagine a universe where gravity had a bit more muscle. Stars would flicker out like birthday candles, vanishing in no time flat. On the flip side, if it were a little weaker, galaxies wouldn't even know they were meant to form. Thankfully, this delicate dance of balance allows for stable orbits and the rhythmic tides we all enjoy. It seems that while chaos reigns across the cosmos, gravity quietly steps in and, like a diligent teacher, restores order. The magic of gravity lies in its role as the ultimate cosmic glue. Picture tiny particles joining forces to create asteroids, planets, and majestic galaxies. They work together in a gravitational tug-of-war, where every pull adds to the collective strength. It's like the universe throwing a massive party, and everyone's invited to bring their mass to the dance floor, except gravity won't let anyone leave until the show ends. Over the course of billions of years, gravity's relentless grip morphs chaotic dust and gas into beautifully structured celestial objects. It's as if our universe is undergoing a cosmic makeover, with gravity as the stylist, crafting everything from asteroids to luminous stars. And let's not forget about light. Even photons, the flashy celebrities of the universe, bend and twist under gravity's compelling influence. It's a wild cosmic spectacle. But the true superhero here is the photon, a charming little fellow with no mass, which enables it to jet across the universe at the speed of light. It's the ultimate long-distance runner, darting from distant galaxies without ever breaking a sweat. You could say that photons are nature's time travelers, connecting the dots of the universe by racing through the void, delivering messages across billions of light years without slowing down. As these photons from ancient stars begin their journey, they pass through the vastness of space to finally reach you. Yes, you sitting there, soaking in the cosmos. The light that's tickling your retinas tonight began its voyage long before Earth was even a twinkle in the cosmos' eye. Talk about a delayed reaction. Not only does the universe have a great sense of timing, but it also knows how to keep you entertained with its celestial light show. Ultimately, it's all thanks to gravity that our universe isn't just a wild, chaotic free-for-all. With its unyielding persistence, this gentle giant shapes the cosmos around us while ensuring that we can still marvel at the beauty of it all. So, the next time you gaze at the stars, remember who's really in charge from the shadows. It's gravity, the quirky force that holds it all together. Imagine a cosmic light show that holds the universe's entire history, a dazzling tapestry woven with photons. the universe's memory. These little messengers zip through the vast void, carrying secrets from the very beginning of time. Think of them as time travelers, speeding along with tales of creation, illuminating the darkness with whispers of stellar births and cosmic events. What a party they throw through the fabric of space. Now, let's talk about the heavyweight champions of particle physics, the W and Z bosons. Unlike our sprightly photons, these guys have some serious heft, about 90 times heavier than a proton. This extra weight means they can't frolic around as freely, leading to some fascinating limitations. They rule over the weak nuclear force, which governs processes like radioactive decay and the nucleosynthesis inside stars. Kind of like a bouncer at a club, only letting the right particles in. These bosons don't hang out long, either. They pop in and out of existence faster than your last New Year's resolution. Their short-lived nature means they can only have a say in the tiniest of arenas, mostly subatomic interactions. Without these fleeting players, we'd be living in a chaotic universe without the delicate balance of stars slowly burning, transforming elements, and creating the very building blocks of everything we know. Meanwhile, we have the ultra-chill gluons and photons who party on without a care in the world. These massless buddies bring their own charm to the fundamental forces. Electromagnetism and the strong nuclear force run in and out of action thanks to them. Photons flash electromagnetic energy, while gluons keep quarks tightly bound together like a family reunion that never ends a little chaotic, but with heart. When it comes to speed, photons don't mess around. They zoom around at the speed of light, spreading their influence far and wide. But just because they fade with distance doesn't mean they disappear entirely. They're like cosmic echoes, whispering through every nook and cranny of the universe, a ghostly presence lingering in the backdrop of our reality. On the other hand, gluons know how to play it safer. They're trapped in atomic nuclei, never straying far from their quark companions. It's a wild ride of strong forces that bind them together, creating a dance that never lacks energy or excitement. While photons unleash light's endless freedom, gluons give matter its solid foundation, making sure the chaos of particles remains under control as they whirl and twirl in their tiny, energetic storms. So, there you have it, a universe driven by delicate balances, quirky particles, and the dance of forces. Though their natures vastly differ, they all play a part in this ridiculous, beautiful cosmic jam that is our reality. Next time you bask in sunlight or feel the solidity of a table, remember the wild party happening in the unseen realms of particles. In an astonishing revelation, scientists have unveiled a universe constructed by massless particles, the true unsung heroes of motion and structure. For ages, the realms of electricity, magnetism, and the weak force were observed as isolated phenomena. However, as experimental breakthroughs peaked into higher energy realms, it became evident that these forces were not just side characters in a cosmic play, but shared a common origin, a twist that gave birth to the electroiac interaction, a true milestone in modern physics. Picture this, at blistering temperatures reminiscent of the universe's early days. Right after the Big Bang, the electromagnetic and weak forces held hands like best buddies, acting as a unified force. It wasn't until the universe decided to cool off, like you taking a cold shower after sweating it out in the summer, that these forces began to separate into the two distinct powers we observe today. This shrinking down of forces heralded a triumph that physicists only dreamed of, highlighted by the significant discoveries surrounding W and Z bosons. These charming little bosons became the main characters in this unfolding drama, revealing the elegant simplicity hidden in nature's seemingly chaotic complexity. With the unveiling of the electroiac theory, physicists were handed a blueprint for their grand dream, a unified framework that entwines all four fundamental forces. Just beneath the surface of complex physical laws lies a single voice chanting symmetry, the echoes of simplicity waiting to shine through the clutter. As physicists cranked up the energy in their particle accelerators, they began to recreate those fiery, chaotic moments of the universe's inception. In this high-energy environment, the once clear lines between electromagnetic and weak forces started to waver, merging into a singular spectacle that could be described with the same mathematical flair. It felt like watching a magician's trick, where separate cards blended into a grand illusion, revealing a bewildering truth about the cosmos. At these extremes, the carriers of each force, the photon, W, and Z bosons, began to shed their distinct identities. It was a cosmic transformation showing the world that at their core, these particles can become indistinguishable in high-energy conditions, reminding us of a time when the universe was a sizzling melting pot of energy. This moment was more than just a scientific revelation. It was a peek into nature's original fabric before individual forces claimed their space on the cosmic stage. Delving into high energy is akin to traveling back in time, navigating through a universe that didn't know division. If the electromagnetic and weak forces could unify under such blistering conditions, who's to say that gravity and the strong force didn't also join hands in that chaotic cosmic dance? Each particle collision and discovery bears the potential to rewrite our understanding of existence, hinting at untold relationships within the fabric of reality. The quest continues, with physicists on a journey to unlock deeper layers of unification in nature. Every experimental endeavor propels us closer to understanding how all these forces might be interconnected in a cosmic embrace, as they weave through the tapestry of space-time. The hope remains that one day, we'll gather all these forces under one roof, exposing the universe's simple yet profound core. And who knows, perhaps the next pet project of physicists will be building a cosmic cabaret, where all four forces can perform a united dance. In the chaotic aftermath of the Big Bang, the universe was a wild, sizzling pot of energy where everything gravity, electromagnetism, the strong force, and the weak force was essentially one big happy family. Picture a cosmic blender, whirring with a massive dose of heat and density, where distinct forces were just figments of imagination. But as the universe began its grand expansion and started to cool down, things got a tad more chaotic. The perfect symmetry of everything came undone. First up to leave the party was gravity. Like that one friend who can't hang with the crowd, it ventured into a dimension of its own. Soon, hot on gravity's heels, the strong force flexed its muscles and broke free, leading to quite a dramatic scene. The electro-weak interaction, which had been a duo act till then, decided to break up, with weak force and electromagnetic force going their separate ways. What an upheaval. This cosmic version of a reality show set the stage for how the universe would behave in the ages to come. When symmetry broke, it was like watching ice melt under the sun. Initially, everything was smooth sailing a unified whole, but as things cooled down, the beautiful symmetry turned unstable. Out of this chaos arose a structured world. New particles made their debut as the universe transitioned through phases, and the once homogeneous landscape burst into a vibrant tapestry of diverse identities. It's like transforming a bowl of soup into an elaborate buffet of cosmological goodies. Now, let's talk about the superstar of the show, the Higgs field. This invisible energy force wades through the vast vacuum of space, lending particles the mass they need to stick around, especially those timid ones related to the weak force. Imagine a neighborhood bouncer ensuring that only those with mass can get past the cosmic velvet rope. Without the Higgs field, the weak force would be like a star without a stage. It simply wouldn't exist. The phenomenon of symmetry breaking sheds light on how the complexity of our universe unfolded from a seemingly simple beginning. It's analogous to a magician performing a trick. What starts off as one cohesive act can morph into a dazzling display of colors and forms. The universe is much like a vast, intricate quilt stitched together from the remnants of its initially pristine condition. Every patch telling a story of what once was a beautiful chaos transformed into the structured elegance we see today. So, here we are, in a universe that is a beautiful symphony of forces and particles, all born from that cosmic shake-up. Every star, galaxy, and atom around you shares a history rooted in that explosive moment. With every twinkle in the sky, you can almost hear the echo of that initial unity, a harmonious swell that once filled the cosmos before branching out into the rich complexity we adore today. The universe may have tempered its chaos, but don't let its serene beauty fool you. It's still an exhilarating ride. As particles journey through the Higgs field, they encounter an intriguing phenomenon. Some get bogged down and chubby, gaining mass, while others breeze through like they haven't a care in the cosmos. Enter the W and Z bosons, the clunky carriers of the weak force. Without this field's mass factory magic, they'd be zooming around at light speed, which is like trying to party with a bunch of energy but finding out none of them can stick around for long. Let's be real, if the Higgs field was missing, we'd be living in a cosmic invitation to boredom. Picture a universe filled with dancing, massless particles darting about, but without the ability to form anything substantial like a solid, organized rave. If everything was zipping along at light speed, our universe would be a chaotic frenzy of radiation, devoid of the atoms that clump together to create everything from grains of sand to the swirling beauty of galaxies. Talk about a dull party. Luckily for us, the Higgs mechanism is the life of the cosmic soiree. It's the behind-the-scenes wizard that gives heft to our existence and allows particles to overcome their frenzied nature. It's like a cosmic glue that helps light and feisty particles slow down, gain some character, and settle down to weave a fiery tapestry of matter. It's the unseen hand that allows everything in our universe to take shape, giving us everything tangible we see and love. Imagine walking through an endless pool of invisible energy. That's essentially what the Higgs field is, the magical ocean that scrunches up light-speed particles, turning them into the solid and noisy things we encounter every day, from colossal galaxies to a mere speck of dust. The heft of existence owes its thanks to this quirky yet vital field. Without it, we'd still be looking at a universe lacking form or substance, battling against the overwhelming ether of light. Now, let's chat about gravity, shall we? Isn't it a riot that in the land of fundamental forces, gravity is the wallflower of the bunch, while we've got photons prancing around for electromagnetism and zugzwangs, or gluons, if we want to be formal, holding the strong force together. Gravity just lounges around waiting for the imaginary graviton to make its entrance. This elusive particle would be a massless wonder sailing through space like a photon. But alas, it remains a no-show in the cosmic club. The graviton is essentially what we'd love to find our golden ticket to understanding gravitational interactions. But detection, almost like trying to find a needle in a haystack made entirely of quantum noise. The feeble strength of gravity at tiny scales means single gravitons are tricky to pin down, like that crumb that slips under the couch after you finish your snack. So far, our best tools have failed to unearth these elusive particles, leaving the mystery of gravity tantalizingly unresolved. With the dance of particles facilitated by the Higgs field and the puzzling absence of a detectable graviton, our universe is a whimsical blend of hard science and delightful mystery. Every twinkling star and every wonder of life owes its identity to these intricate interactions and forces an unseen sitcom unfolding in the vastness of space. Buckle up, it's an enthralling ride through the cosmos. Gravitons have been the elusive characters in the play of quantum field theory, slipping through our fingers like confetti at a parade. These hypothetical particles would theoretically sprout from the gravitational fabric of the universe, with no mass to weigh them down. If they exist, they'd zoom around at light speed, much like those pesky photons that keep stealing the limelight. Yet, while photons dance boldly in visibility, gravitons stealthily pull the strings of gravity from the shadows. Mischievous little critters, aren't they? Now, here's the kicker. Scientists believe that if gravitons are indeed out there, proving their existence is akin to trying to catch smoke with bare hands. The interactions they create are subtle, detectable only when supermassive celestial bodies or cosmic rock stars collide. Instead, we've resorted to snooping on gravity's effects through gravitational waves, those cosmic ripples that announce the dramatic adventures of black holes. It's like reading the universe's diary entries from a safe distance, each wave whispering secrets of its mind-blowing escapades. As we chase these ripples, the idea of gravity being more than just a force becomes captivating. What if gravity is merely an illusion cast by the deeper laws governing quantum information? Picture this: space and time as theater props, emerging from complex patterns of entanglement, the invisible threads tying particles together. In this whimsical universe, gravity might just be a byproduct of how information behaves, casually rearranging itself in the cosmic jig. Who knew reality could be more like a well-orchestrated dance than a rigid stage? This revolutionary thought flips the script on our understanding of gravity. If it's not a fundamental force but spawned from something more profound, then gravity takes on the same vibes as something like temperature, only an emergent cheer of cheerleaders collectively cheering on the aspects of molecular motion. It's like discovering that the melody isn't composed solely of notes, but instead is a song that emerges from the harmony of deeper themes. Who wouldn't want to belt out a whole new world at that revelation? But wait, additional dimensions. Some physicists are raising their hands and shouting, "Hey, over here, They suggest that exploring extra dimensions might offer a backstage pass to the reason gravity plays second fiddle to other forces. Instead of being a standalone star, gravity could be a shy backing vocalist, whispering its low notes compared to the loud cheers of electromagnetism and strong nuclear forces. It's a cosmic jam session where gravity is still important but stays modest amidst the grand crescendo. So, whether it's weaving quantum information, swirling through extra dimensions, or tiptoeing around hidden logic, gravity is in for a wild reinterpretation. We stand on the hill of discovery, eagerly awaiting the cosmic fireworks that might reveal the truth. If it turns out that our sense of space, time, and gravity is merely a holographic projection, a delightful illusion crafted by the universe, then we've hit the jackpot of cosmic mysteries. Life, my friends, wouldn't that be the ultimate plot twist? Some physicists boldly argue that gravity's well-known weakness isn't just a cosmic joke. It might be a bold hint about the universe's secrets. Imagine if gravity, rather than being what it seems, is actually sneaking away into hidden dimensions that we can't see. According to string theory, our universe is like a multi-layered cake with additional dimensions tightly rolled up. Unlike the other forces that remain contained, gravity spreads out into these unseen realms, losing some of its punch in the process. This intriguing notion could finally explain why gravity seems like the awkward cousin at the family reunion of forces. While electromagnetism and nuclear forces flex their muscles, gravity, in comparison, behaves like the class clown. Scientists are hard at work with particle accelerators to test this theory out further, hoping to stumble upon proof of these hidden dimensions. If they do, it would be like discovering a secret door to a universe jam-packed with bizarre and mind-boggling possibilities, a realm where gravity glides off quietly, escaping our observational grasp. Now, let's drift into the heart of our own fiery star, the Sun. Picture this. Deep inside the Sun, two colossal forces are locked in a fierce tango. On one side, gravity, with its relentless inward pull, is trying to squeeze the whole thing into a supernova-sized ball of gas. On the other side, nuclear fusion is bursting forth like a sky full of fireworks, countering the gravitational embrace like an undefeated champion. This dazzling duet maintains a perfect equilibrium, preventing our Sun from either puffing up like a balloon or collapsing in on itself. Without that balance, things would get wild, and let's face it, not in a good way. If gravity got a bit stronger, our Sun would shrink, heat up, and burn out faster than one of those overpriced candles at a fancy restaurant. On the flip side, if fusion decided to turn the volume up, the Sun would balloon out, cool down, and become a dim, less productive neighbor in the sky. But thanks to the cosmic dance between these two forces, we have a Sun that's been a reliable source of warmth and light for billions of years. Can I get a thank you for all those rays of sunshine? The Sun, in a way, is like the ultimate reality show star, hiding its tumultuous struggles beneath a blissful surface. It's an ongoing battle of gravitational love versus fusion fury, all while keeping us snug and toasty. Every single ray of sunlight that graces us on Earth is the tangible result of this cosmic choreography. What could be more poetic than that? Each beam we bask in tells the story of a stellar fabric woven by conflict and harmony. But let's not stop here. Each star peppering the night sky is doing the same jig between gravity and fusion. Tiny red dwarfs to gigantic supergiants all showcase this grand tension, oscillating between the push and pull of these opposing forces. Gravity may be pulling inward with all its might, but fusion responds with an equally forceful extension outward. The result, a glorious explosion of light that twinkles through the cosmos. The brightness of a star shines not just for our viewing pleasure but serves as a glowing emblem of that celestial balance. Every shining dot represents an ongoing fight between two titans, reminding us that the universe thrives on contrast, on the interplay of differing energies that creates something magnificently beautiful. So next time you gaze at the night sky, imagine the monumental struggle behind each flicker of light as gravity and fusion keep the cosmic dance alive. In the cosmic dance of life, stars are constantly juggling two dominant forces, the relentless pull of gravity and the fiery push of fusion. Imagine this galactic epic as a dynamic tug of war, where stars either implode dramatically into a black hole or puff up into a colossal giant before taking their graceful bow. What we perceive as serene twinkling lights in the night sky is actually a high-stakes battle where energy and matter engage in a cosmic high five, or sometimes a cosmic slap. When gravity wins, the scene turns grim. There are starry souls out there whose struggle cannot outlast their inner battles. As they run out of nuclear fuel, the zest for fusion fades away and gravity launches an all-out offensive, crushing their cores like a celestial junkyard for massive stars. That means even the tough as nails neutron pressure can't put a stop to the collapse, leading to a celestial pinball effect where space-time itself contorts and folds inwards. Cue the black hole, everyone's favorite cosmic conundrum. Now, what's a black hole, you ask? Picture an insatiable vacuum with such a gravitational grip that not even light can wiggle free. These cosmic behemoths mark the boundaries of observable reality with their event horizon. Basically, it's the do not enter sign of the universe. On the other side, the rules of physics throw out all logic and dance wildly in their own chaotic festivity. Black holes aren't evil entities plotting to swallow the universe. They are simply the aftermath of gravity, turning everything into a universe-sized party trick. Next up, we have the white dwarfs, the cosmic leftovers where gravity and quantum mechanics engage in a cheeky standoff. When stars like our trusty sun finish their fusion buffet, they toss off their outer layers and leave behind a dense, hot core, akin to the embarrassing but lovable remnants after a wild party. These little hotshots are packed to the brim, balancing on the razor-thin line of quantum pressure, literally squeezing the life out of everything within. Electron degeneracy pressure steps in like a superhero just in time to save the day. This phenomenon is where electrons refuse to huddle together in the same state, creating just the right amount of pushback against gravity. The result, a precariously balanced white dwarf that's crammed with the mass of our sun but shrunk down to the size of Earth. These glowing orbs take their time cooling off, taking billions of years to fade away while offering a fabulous light show. But not everything stays nice and cozy forever. If a white dwarf gets a little too greedy and adds extra mass to its caseload, that newfound weight gives gravity an upper hand. This prompts a dramatic party crash, leading to either a spectacular supernova explosion or a transformation into a neutron star. Talk about dramatic exits, the universe certainly knows how to throw a fitting farewell. So, while we gaze at the peaceful sky above, remember, each twinkling star has its own saga of collapse and expansion playing out in heart-racing cosmic drama. It's a thrilling play of forces, an eternal chess game with the universe itself as the grand stage. The destiny of stars reflects not just a battle, but an intricate balance sustaining the dance of the cosmos, where every flicker holds the tales of lifetimes, both amazing and tragic. White dwarfs, those tiny celestial embers, are like the afterglow of burnt-out stars, cozying up to a fragile balance of existence. They're a whisper of light in the vast darkness of space, proving that even after their luminous lives end, stars can still stick around for a while, snoozing quietly in their cosmic retirement. Just when you think they've gone cold, here comes the neutron star, the heavyweight champ of stellar leftovers, packed tighter than your favorite suitcase after a shopping spree. Now, imagine a star going out with a bang. Literally. When a massive star reaches its final crescendo in a supernova explosion, its core undergoes a super dramatic weight loss, squishing into a neutron star. At this point, protons and electrons throw a wild party, joining forces to become neutrons. The result, an object of mind-boggling density. We're talking enough crunch in just a teaspoon of neutron star material to send billions of tons soaring. Talk about heavy lifting. In this stellar showdown, gravity is the ultimate heavyweight, smashing inward with an intensity that makes gym enthusiasts drool. But here's where the plot thickens. The strong nuclear force, that stubborn little dynamo, pushes back against the gravitational squeeze. It's a brawl at the boundary of physics where tension and balance create some of the universe's wildest attractions. Picture mountains that can barely budge. Capped at just a few millimeters in height, there's no room for elevation around here. Then we have pulsars, the stellar spin doctors of the galaxy. These super speedy neutron stars rotate so rapidly, hundreds of times a second. They'd give any DJ a run for their money. As they spin, they send beams of radiation zipping through space, reminiscent of cosmic lighthouses. It's like they're giving a light show on an intergalactic scale, reminding us that in the depths of chaos, Stability emerges when the forces of nature decide to play nice over a few billion years. And speaking of chaos, enter the supernova, the cosmic equivalent of a dramatic final act. Here, all four forces of nature collide like children in a candy store, pushing the limits of physics and creating something truly extraordinary. Gravity relentlessly pulls the star's core inwards, while the strong and weak forces unleash a whirlwind of atomic reshaping. Zooming faster than a caffeinated cheetah, it's an epic moment where energy bursts forth, flooding the cosmos with light brighter than 1,000 suns. This grand explosion does a wild dance with elements gold, silver, and uranium are forged faster than you can say "let there be stars." These heavy elements are flung into space, sowing the seeds of new worlds and new beginnings. In the wake of a supernova, it feels less like an ending and more like the universe's way of hitting refresh. Each brilliant event showcases the fierce power of the fundamental forces, reminding us that birth often comes wrapped in the fabric of destruction. And while the electromagnetic force conducts its own show, repelling and attracting like a cosmic tug of war, the strong force stands its ground, holding everything together with dogged determination. Sure, we're familiar with electromagnetic antics like how magnets cling or summer thunderstorms rumble across the sky, but the strong nuclear force, now that's an entirely different kettle of cosmic fish. It binds atoms together tighter than a family reunion, refusing to let go, proving that in the realm of the universe, some things are just meant to stay inseparable. Inside the nucleus of an atom, you'd expect protons to be in a frantic game of push and shove, wanting nothing more than to repel each other with air-like charges. But surprise, the strong force swoops in like a superhero, overpowering the electromagnetism that should tear them apart. In fact, the more those protons squirm away, the harder the strong force clamps down, as if the universe itself is saying, "Not so fast." It's quite the cosmic partnership of resistance. Scientists, armed with their particle accelerators, have tried to pry apart quarks, thinking they could liberate them like prisoners. Instead, they end up with an unintentional science fair, create a new particle day. Each attempt to separate these feisty little guys results in an explosion of new particles, proving the strong force is not only a glue but also a gatekeeper of unity. This force keeps everything connected, maintaining the fabric of the universe in one neat package. Now, let's talk magnets, those little life hacks we marvel at. Think of a magnet as a tiny army of trillions of atomic spins that are perfectly in sync, marching to the same beat. The source of this alignment, every electron has its own spin, and when they point in random directions, they essentially cancel each other out. But when they decide to coordinate, voila! A magnetic field strong enough to lift objects from a distance and store secrets within metals is born. It's a staggering phenomenon. Picture this. The magnet in your hand is a jubilant showcase of atomic cooperation, a quiet miracle of how unity at minuscule scales results in major power plays at larger ones. When conditions are just right, like giving certain materials a chill or placing them in a strong magnetic field, this order emerges, creating magnetic magic that baffles the mind. Now, let's crank up the intensity and look at pulsars, true cosmic rock stars. Picture a massive star collapsing into a sphere smaller than your average city, yet heavier than the sun. Yep, a pulsar is that kind of extreme, spinning at dizzying speeds, sometimes hundreds of times per second. These celestial bodies aren't just compact, they come with mind-boggling magnetic fields, 1,000 trillion times stronger than Earth's. Talk about an overachiever. Standing near a pulsar is like having front row seats to a galactic fireworks display. This incredible magnetic field is so powerful, it can yank electrons right out of atoms, ionizing matter across breathtaking distances. Space around a pulsar transforms into a whirlwind of radiation, as magnetic lines twist and dance like energetic ropes of fire, a wild cosmic party that's anything but boring. In the end, whether it's the silent union of atoms within a humble magnet or the fiery spectacle of a pulsar, the universe is a grand show of cooperation and power. From the tiniest particles to the most magnificent celestial bodies, everything dances to a rhythm of forces, each contributing to the beautiful, chaotic masterpiece we call existence. So, the next time you hold a magnet or gaze at the night sky, remember the delightful drama unfolding beyond your sight. As celestial wonders whirl through the cosmos, pulsars stand out, firing beams of energy like interstellar lighthouse beacons. These mesmerizing cosmic clocks beam rhythmic pulses with impeccable timing, outshining even the most accurate human-made devices. If you thought keeping time was tough, just wait until you try synchronizing with the spinning remnants of a supernova. Pulsars reveal a universe where magnetism molds not merely matter, but indeed the very fabric of space-time itself. Imagine lightning as nature's ultimate energy burst. A single bolt unleashes enough electricity to power an entire city, if only for mere seconds. Talk about a short-lived party. It all starts when warm air rises while rain descends, creating a shocking separation of electric charges. As the tension builds, the atmosphere finally can't take it anymore, and boom, a spectacular surge of current zigzags across the sky, reaching temperatures that would make the sun blush 30,000 degrees Celsius. What goes up must come down, and lightning doesn't disappoint. It elegantly dances both upward and downward, forging connections between clouds and the earth in a beautifully chaotic web. Each flash of plasma is an electrifying reminder of the cosmic ballet between the heavens and our terrestrial domain. This spectacular sight is a true testament to the wild and whimsical workings of electromagnetism, forming an electrifying bridge that connects sky to soil. Electromagnetism isn't just a stormy spectacle, it's the universe's builder. Every electric current generates a magnetic field that wraps around it like a loyal puppy, always close by. Curious about how it works? Well, when charges are on the move, they create a magnetic field that spirals around them in perfectly neat circles. This dazzling interplay of electricity and magnetism was first unearthed by the brilliant Hans Christian Ørsted back in the thrilling year of 1820, revealing just how intertwined these forces are. The implications of this unity are nothing short of electrifying. These principles are the driving force behind a myriad of everyday wonders, from whirring electric motors to the magic of wireless communication, making life in the digital age a whole lot more interesting. Even the tiny flickers of electricity zipping around in your brain contribute to this cosmic dance, generating faint magnetic fields that scientists can measure easily with their oh-so-delicate instruments. So, every time you flip a switch or check your Wi-Fi, know that you're tapping into a cosmic connection that stretches from the tiniest cells in your brain to the fierce, spinning engines of pulsars billions of light years away. It's like having a universal backstage pass to the wildest show in town, as lightning splits the sky and pulsars tick away in the cosmos. Remember that science isn't just a bunch of numbers and theories. It's an extraordinary adventure unfolding at every turn. Imagine the Earth's core as a huge molten iron roller coaster, zipping along while generating a magnetic force field so powerful it's like a cosmic shield. This magnetic field isn't just a protective layer, it's an intricate tapestry woven together by the dance of electricity and magnetism. Think of it as a playful shadow, twirling around every bit of energy flowing through our planet. Who knew that even the tiniest movements could shape the very fabric of reality? Every time an electron zips across space, it doesn't just take a lazy stroll, it's on a mission. As it sprints, it drags along a party of electromagnetic fields that expand in every possible direction. This little guy is not a lone adventurer, it's a force of nature, influencing the behavior of its particle neighbors. Picture it like a magnetic game of tag, guiding how the energy interacts with everything in its vicinity. Talk about a little powerhouse. Now let's spice things up with quantum theory. When it comes to our little electron friend, there's more than meets the eye. It's cloaked in a mystical vapor of virtual particles that pop in and out of existence like a magician performing sleight of hand. These whimsical particles subtly enhance the electron's electric field, almost like an entourage waiting to back it up, and when it picks up speed, it sends waves of electromagnetic energy rippling across the universe, like fireworks igniting the night sky. Each flicker of electricity, each beam of light that bursts forth all traces back to our busy buddy the electron. Even though it's as tiny as a speck of dust, it's constantly shaping our universe's invisible texture with its zippy antics. Imagine throwing a pebble into a smooth pond and the ripples expanding endlessly. This is how each electron pushes and pulls the very threads of space-time. But wait, we can't forget about the strong force. This heavyweight powerhouse is run by gluons, the ultimate glue of existence. Think of gluons as the unsung heroes battling it out in the particle world, binding quarks into protons and neutrons with finesse. There are 8 kinds of these colorful little critters: red, green, blue, and their opposites playing their roles in a cosmic color-coded game. Spoiler alert. These colors aren't about aesthetics, but mathematical principles that define how quarks play ball. Inside atomic nuclei, it's a wild and vibrant world thanks to the constant exchange of gluons. These energetic little guys create an ever-evolving storm of interaction, ensuring that quarks stay snug and cozy together. And let's not forget, gluons themselves love a good chat. They carry color charge, meaning they're always in the mix. It's a fabulous chaos that challenges physicists, making the equations of quantum chromodynamics the intellectual equivalent of a jigsaw puzzle with missing pieces. Yet amidst this bustling turmoil, the universe finds balance. The 8 majestic gluons work in concert to craft perfect stability from this cacophony. They transform raw quantum energy into the sturdy matter that makes up everything you see around you, an amazing feat of cosmic engineering. So the next time you marvel at a piece of rock or a starry night, remember the fantastical dance of electrons and gluons hard at work to keep our universe vibrant and whole. Gluons may be the tiniest of particles, but their impact is colossal, creating nearly all the mass we perceive in the universe. It's a delightful brain teaser. How can something massless help form the heavy stuff of existence? Well, these little powerhouses ensure quarks, the fundamental building blocks of protons and neutrons, stay glued together through a never-ending exchange of energy. It's like a high-speed game of catch, but with enough energy to outweight the quarks by 1,000 times. No less. Picture this: every time you pick up a rock or even clench your fist, you're not just holding solid objects, you're grasping a hefty bundle of energy. This energy isn't just lounging around, it's bustling with activity, thanks to the gluon hustle. According to Einstein's theory, energy and mass are two sides of the same coin. So, the relentless energy generated through the strong force becomes the mass of protons. It's a fantastic twist of physics that highlights that what we call weight is really just stored energy frolicking in its tiny, confined space. Now, shift your attention to the weak force, a different player in the particle world. This mischievous force is all about change, orchestrating the dance of radioactive decay within atomic nuclei. Picture unstable atoms as indecisive partygoers, neutrons swapping outfits with protons while tossing out electrons and neutrinos like confetti. The weak nuclear force supports this transformation. Despite having a range so small, it could practically fit in a proton's pocket. Why is this funky force important? Oh, it's vital for the evolution of matter itself. It governs how long certain isotopes last and how elements transform over eons. Think about it. Without the weak force, all those stars we admire at night would perhaps be dim flickers rather than bright celestial bodies. It ensures that relentlessly fiery stars maintain their glow, gradually creating new elements essential for life. Feel the significance ripple across time. The weak force shapes not just the atoms we're made of, but also the geological wonders beneath our feet. From the warmth simmering in Earth's core to the ancient rocks telling tales of ages past. This understated force is at the heart of it all, like a cosmic maestro. It determines the tempo at which matter evolves, marking its rhythm across epochs that outlast humanity's fleeting moments. As we stand under a starry sky, it's fun to think of the unseen forces working tirelessly behind the scenes. The weak force is the quiet operator pulling strings for the grand show we call the universe. Its subtle nuances guide the transformation of matter through time, proving that while we may not see it, it's an essential player in this cosmic ballet of existence, reminding us of the delicate balance of creation right above our heads. Deep within the Earth, a sizzling cauldron of radioactivity works its magic. Picture this: uranium, thorium, and potassium are breaking down like ancient party animals, throwing energy-packed particles into the mantle and core. This constant decay generates heat and keeps the interior of the planet molten, like an underground lava lamp. Those squishy convection currents in the outer core are the real MVPs, powering our planet's magnetic field that dances around us. Now, let's talk about that magnetic field. It's not just for show, it's like Earth's very own superhero shield, warding off harmful solar radiation and cosmic rays. Imagine cosmic rays like intergalactic bullies trying to crash our planet's party. Thankfully, our magnetic field is there with a big knot today. If it weren't for the unassuming yet relentless work of radioactivity, Earth would have long since cooled, becoming a sad, barren rock. And let's be real, that's just no fun. On the surface, We've got volcanoes popping molten confetti and earthquakes throwing unexpected dance parties. They're all thanks to that atomic heartbeat pulsing inside the Earth. It's like the planet is thumping to its own rhythm, keeping everything dynamic and exciting. The weak force may be shy and nearly invisible, but it plays a critical role in maintaining this lively atmosphere, ensuring our complex ecosystem stays vibrant and alive. Speaking of dynamics, let's take a leap into the wild world of quantum mechanics. Here's the kicker. While gravity molds the cosmos into neat shapes, quantum mechanics reveals a reality that's anything but smooth. Imagine time and space as a frothy coffee, bubbling with energy and particles constantly appearing and disappearing like magic tricks. This chaotic dance means space and time are not just stable backgrounds. They're alive, shifting, changing at a moment's notice, and always keeping us guessing. Now, if we could shrink ourselves down to the Planck scale, things would get downright topsy-turvy. Distances would start having an identity crisis, blurring together, and time would shimmer like a mirage in the desert. Picture time acting like it's on a roller coaster, with ups and downs that feel entirely unpredictable. At this scale, gravity might turn into a mere suggestion rather than a strict rule, emerging only from the quantum chaos swirling around us. In the grand scheme of things, it's pretty wild to think that the smooth realities we use to adjust averages over a tumultuous sea of uncertainty. Physicists everywhere are diving headfirst into this muddle, trying to stitch together a quantum theory of gravity. They're after a unified theory that can make sense of our big universe and the tiny particle world, both of which currently dance to their own incompatible beat. Right now, modern physics stands strong on two shaky pillars: general relativity handling the grand scale and quantum mechanics ruling the microscopic realm. Both have their unique strengths, kind of like the odd couple of science, yet they can't seem to find common ground. General relativity offers a pristine, smooth narrative of space-time, while quantum mechanics reveals a chaotic, vivacious underpinning. Who knew the universe was such a captivating blend of stability and wild unpredictability? Quantum mechanics is like that enigmatic cousin at the family reunion, full of probabilistic surprises and uncertainty that keeps everyone scratching their heads. Scientists have tirelessly sought to bring together the wild world of quantum mechanics and the reliable realm of gravity into one grand theory. The contenders, string theory, suggesting that everything is made up of vibrating strings, and loop quantum gravity, which posits that space-time is a patchwork of tiny loops. It's as if the universe is a cosmic fabric, waiting for someone to sew all the pieces together. Enter the experiments looking for whispers of these theories hiding in gravitational waves and the smoky remnants of black holes. Picture this: a groundbreaking quantum theory of gravity could unravel the mysteries of the universe, revealing secrets instantly after the Big Bang. It would link the infinite cosmos with the tiniest particles, creating the ultimate scientific bridge. Imagine bridging the gap between infinity and the microscopic talk about a cosmic tightrope act. Have you ever thought about the gravitational waves gliding through you? Those invisible ripples are like the universe's own lullaby, ever present yet unnoticed as they stretch and squeeze the fabric of space around us, every second. These waves, generated by cataclysmic events like black hole collisions, dance around us, altering the distance between our atoms by unfathomably tiny amounts, thanks to Einstein's insights. These gravitational symphonies were finally detected in 2015, proving space isn't just empty, it vibrates like an ethereal fabric. Despite carrying unimaginable energy, the effects of these waves are so minuscule that only the most high-tech gear can pick up on their secrets. Imagine catching a whisper from across the universe. That's what these waves represent. A gentle reminder that even as we go about our day, we're swaying to the gravitational rhythm established eons ago. Every heartbeat aligns with this cosmic music, uniting all existence in a melody older than time itself. Who knew we were all unwitting dancers in the grand ballroom of the cosmos? Now, let's talk about magnetars akin to the cosmic bullies of the universe. These ultra-magnetized neutron stars simply don't play nice. When a massive star meets its end, it leaves behind a magnetar, with a magnetic field so powerful that it can erase your credit card's data from light years away. Imagine your payment method being wiped out just because you glanced at the sky, with fields 1,000 trillion times stronger than Earth's. These stellar behemoths can twist atoms and manipulate light, truly mind-boggling. Getting closer to a magnetar, not a great idea. They can shred matter at the atomic level, turning solid structures into cosmic confetti. And just when you think that's enough chaos for one star, they can unleash dazzling flares of gamma radiation that outshine entire galaxies, proving that even in the cosmic realm, Shobi still reigns supreme, as their crusts crack under intense pressure. Bursts of energy are released that could even alter the star's own spin. Now that's an after party you wouldn't want to miss unless you're made of matter, of course. So, as the universe unfolds its intricate dance of quantum mechanics and gravitational waves, we're left marveling at the cosmic symphony around us. Whether we're being serenaded by flitting gravitational waves or caught in the magnetic embrace of a magnetar, the universe is a lively and unpredictable place. Just keep your fingers crossed that the next cosmic event isn't your electronics flying across the room. In the cosmic carnival of existence, magnetars reign as the universe's heavyweight champions of magnetism. These stellar oddities are like celestial reminders that even the ghosts of deceased stars can flex their magnetic muscles. Imagine a star's afterlife being just as electrifying. Magnetars flaunt magnetic fields that can wrap around entire planets, proving that the forces of nature can be both extreme and strangely captivating. Meanwhile, our sun performs its own spectacular magic by transforming hydrogen into helium with the help of the weak force. Picture this: deep within the sun's sizzling heart, where temperatures soar and pressures crush, hydrogen atoms collide like enthusiastic party guests at a jam-packed dance floor. But hold on, without the weak force stepping in like an energetic DJ, those hydrogen atoms would never unite to form deuterium, leading us down the path to producing the glorious helium that makes our sun shine bright. The weak force may seem subtle, like a shy wallflower at a dance, but it plays a pivotal role in igniting stars. If left to its own devices, even the hottest and most compressed conditions wouldn't suffice. It's the unsung hero creating a cosmic chain reaction that fuels the sun's radiance. When the sun releases its energy, it radiates across the solar system as light and heat, warming our chilly Earth, reminding us of the depth of this stellar symphony. With every ray of sunlight warming your skin, remember that it's not merely light, it's the culmination of billions of years of atomic dance under the watchful eye of the weak force. Think about it. The very particles buzzing around in your body once teemed within ancient stars. The oxygen in your lungs, carbon scurrying in your cells, and even the calcium ticking in your bones are all star-made treasures. That's right. Each atom carries with it the echoes of a supernova party that allowed for the birth of life on Earth. When those mighty stars reached the end of their cosmic journey, they went out in glorious explosions, scattering the precious materials forged in their cores across the universe over eons. This stellar debris drifted and coalesced into dazzling new systems, one of which eventually sprouted the Earth. Everything you see, every breath you take, and each movement you make depend on this ancient stardust that has shaped life as we know it. In a beautiful twist of cosmic fate, the weak force connects all living creatures to the heartbeat of the cosmos. It threads every life form, linking them back to the very furnace of creation from which we all sprung. It's a gentle reminder that the matter that makes up our lives is intricately woven with that of the stars. A poetic bond that emphasizes the shared origins of everything found within the vast theater of the universe. The wonder doesn't stop there. The strong force swoops in, ensuring that our universe, while dazzling, holds substance beyond mere radiation. Imagine a universe where quarks are rebellious free spirits, refusing to play along. Without the strong nuclear force, these tiny building blocks would float apart, and protons and neutrons would be mere figments of our imagination. Instead, we'd be surrounded by an endless sea of blinding light and frenetic energy, a chaotic party with no guest list. But thank goodness for the strong force. It slaps those quarks together, converting energy into matter, crafting a universe that feels as real as your last terrible haircut. The strong force is like a cosmic architect, giving shape and texture to the universe. It locks energy within particles, transforming wild radiation into something substantial. Picture it as the universe's ultimate project, turning void into magnificent realities. Thanks to this magic, everything from rocks beneath our feet to towering trees arises from the strong force's handiwork, making chaos look good with its orderly design. Basically, it's nature's continuous act of creation turning uncontrolled energies into beautiful buildings of existence. Now, let's chat about gravity. Once the strong force lays down the law and creates matter, gravity swoops in like the meticulous organizer you never knew you needed. It slowly, but surely, gathers all that dust and gas, molding them from shapeless clouds into dazzling stars and vast galaxies. In the grand cosmic ballet, gravity is the persistent partner guiding every heavy-footed dance move, ensuring the universe gets sculpted into those breathtaking structures we love to gaze at and be mildly confused by. Are you wishing for planets and life? No gravity, no chance. Without its gentle grip, matter would be just drifting through space as lost as your socks in the laundry. With gravity's steady pull, everything finds a place, and the fusion of particles ignites, illuminating the universe and giving everything a cozy, solid feel. It finds order amid chaos. Like turning a messy bedroom into a livable space, though we all know it rarely stays organized for too long. Together, these four forces form the ultimate avengers of the cosmos: gravity, electromagnetism, the strong force, and the weak force. Each one plays its part like a musician in the greatest cosmic symphony good old Mother Nature has ever composed. Imagine gravity gathering matter like a bouncer at a nightclub, electromagnetism conducting light like an illuminated maestro, the strong force binding nuclei tighter than a starry-eyed couple, and the weak force transforming elements inside stars. Like culinary magic. Yet, here's the kicker: mess with even one of these forces, even just a tad, and voila, the whole cosmic concert falls out of tune. No stars twinkling against the velvet night, no chemistry making life possible, and let's be honest, definitely no backstories of existence. It's a delicate balance. The perfect one-liner perfectionists talk about a cosmic equilibrium holding it all together, ensuring that the universe doesn't just float away into nothingness like a balloon that's lost its air. So next time you stare up at the night sky, remember the dance of the forces at play, creating this wondrous reality we call home. It's a mind-bending spectacle, gathering bright stardust, fusing atoms, and igniting life, showcasing the whims of the universe and reminding us just how spectacularly bizarre and vibrant existence can be. And trust me, it's way better than just a random sparkle in the dark. Every heartbeat you feel, every twinkle from a distant galaxy, and every flicker of intelligence is like poetry woven into the fabric of existence. It's not a random compilation of laws, it's a grand melody played by the cosmos itself. Think about it, everything that exists is merely an echo of this harmonious tune. The universe isn't just cluttered with things. It's a racetrack of forces constantly playing tag and creating a vibrant spectacle. Dive deeper, and you'll discover that what we perceive as solid matter is all a trick of the eye. Atoms are just temporary wrinkles in a field that's alive with action. These subatomic particles exist due to interactions that never hit the brakes. The four fundamental forces don't just sit around. They're like the action verbs of existence, sparking a never-ending chain reaction that stitches reality together moment by moment. Atoms bond together through a spectacular exchange of energy, forming just enough stability to keep chaos at bay. Look at the stars shining brightly, they owe their brilliance to a delicate balance of forces. And let's talk about life. It's a miraculous endurance act made possible by maintaining these cosmic balances. The universe is anything but a stagnant bowl of jello. It's more like a dynamic performance, where energy shapes itself based on the ongoing tension of competing forces. When you step outside, every mountain and ocean you see dances to the rhythms of energy. Those grand landscapes are the slowest ripples in the cosmic tide. To get a grip on this magnificent universe, one has to appreciate that it's not built brick by brick. It's more like witnessing a fluent ballet of gravity, electromagnetism, and nuclear forces that has continued since time began. Now, as the cosmic currents take a breather, you find yourself nestled in a moment of calm. The forces spinning this grand reality don't clock out, they just gently invite you to relax. Feel gravity's cozy embrace pulling you to the earth, like a snug blanket reminding you that you're firmly tethered here, feeling the planet's mellow heartbeat beneath your feet. Electromagnetism is like the universe's soothing vocal cords, radiating warmth that kisses your skin. And let's not forget the strong and weak nuclear forces diligently at work inside you, holding atoms together and your body alive. It's a mind-blowing realization that every sound, every breath, every fleeting thought is a product of this delicate balance. Remember, You're not some isolated speck lost in the void. Oh no. You are a vibrant thread in the cosmic tapestry, a beautiful expression of forces momentarily becoming conscious and making sense of the vastness. Embrace it. You're a stunning aspect of the universe, intricately dancing in perfect rhythm for a thrillingly brief yet beautiful moment in time. In the grand tapestry of the universe, galaxies lazily drift apart, weaving tales of time and mystery. The birth and death of stars dance to a tune that resonates within you, every heartbeat marking a rhythm older than time. It's a cosmic jam session, where you're not just an observer but a participant, crafted from the stardust of long-gone supernovas. Feel that every moment pulses with a history that's as boundless as the night sky. Now, let those thoughts of yours start to loosen up and tumble down, like cosmic dust caught in a beam of starlight. It's like a cosmic confetti party, and you are the VIP. The gravity that pulls you down isn't just a force, it's a warm embrace, a reminder that you're snugly part of this grand spectacle. An electromagnetic symphony plays in the background, whispering sweet nothings while nuclear reactions fuel your very existence. Take a pause amidst this universal hustle and bustle. In the stillness between your breaths lies a magical doorway leading to dreams and sleep. Enter that serene space where the cosmos is always in motion, its beauty unfathomable yet comforting. Let each sigh be a step towards tranquility, floating lightly with every inhalation, as the universe wraps you in its celestial arms, assuring you everything is as it should be. As you journey into this peaceful repose, remember the joy of these silent excursions through space and time. It's like a cosmic road trip without a map, where every corner reveals a glimmering wonder. If you've ever enjoyed these meanderings through the stars, don't be shy, give a thumbs up, hit that subscribe button, or drop a thought below. Share this cosmic ride, one dreamy traveler at a time. Imagine, just for a moment, the weightlessness you'll feel as you surrender to the gentle lull of the universe. Picture your eyes growing heavy, gradually drifting shut, as if the night sky itself is whispering a sweet lullaby just for you. The forces of the cosmos gather around your thoughts, cradling them like a parent tucking in their sleepy child, making sure you're snug and safe. As you let go of the day's worries, know that you are made of the same particles that twinkled in distant stars. Each pulse of light above serves as a reminder that you are part of a magnificent story. So breathe easy, let your dreams take flight, and surrender to the vast, comforting embrace of the universe. Good night, stargazer. Close your eyes and drift off into that lovely cosmic sea, where every twinkle is a promise of serenity and every shadow is a story yet unwritten. There's a whole universe waiting just behind those eyelids.